Sean Reid. Sean.
Good morning, everybody. Glad you made it. Final day. If you're not fatigued by now, we hope to wake you up this morning. So the next session is going to be about AI in the role of entertainment and storytelling, but particularly with interactive entertainment and storytelling. And the format this morning, we're going to have 2 talks, short presentations by Guy Gadney of Charisma AI and then Laura Harrison of the BBC, and then we're going to go into a panel discussion with a few more guests. So welcome in Guy. Laura first.
Hello everyone. So I'm Laura Harrison from BBC Research and Development, and today Guy and I are hopefully going to try and answer the question that is AI making storytelling more interactive. And I'll talk a bit about some of the things we've been experimenting with in R&D, what challenges we've faced, and what we've learned right through from exploration to testing. And there's so many things I could have talked about today, but I managed to narrow it down to just 3 content areas. And those are news and factual, object-based experiences, and drama and storytelling. So what do I mean when I'm talking about AI in this context? So firstly, and most commonly, I mean sort of machines that have been fed big data sets where they can understand the differences and anomalies and surface points of interest to the user. But secondly, I mean the progression of machine intelligence technologies such as branching narrative that sort of moved us from more of a lean back and absorb approach to a lean forward and play experience. So lastly, beyond that, the machine intelligence, how can it add value to the experiences in some way? So back to my 3 examples. The first is just in news and factual. So recently, BBC News Labs have been experimenting in something called semi-automated journalism with local news services. So people today know more about what's happening in their local communities because of social media, obviously. But sustaining local news has become increasingly a bit more of a struggle because of this. So the team at BBC News Labs wanted to ask the question of, could AI help them in creating more relevant stories for local audiences with adapting expectations? So they used huge data sets from the NHS for this. As you can see, this is part of the process pipeline. So they take the data sets from the NHS, then using natural language generation, they create a story for every local NHS trust. Then there's also an automatically generated graphic for each story. And usually this process takes a few months, so being able to create generic templates has made this a huge step forward. And then it's just up to the journalist to then verify the story, which is the most important bit, before publishing to audiences. So obviously there are challenges here and some interesting questions before the team got started. You know, will journalists be comfortable in publishing stories that they haven't actually written themselves? And will audiences actually be happy reading stories that were compiled by machines? And there are some sensitivities, as we know, about what AI means in this area around trust, particularly with the rise of deep fakes and the spread of misinformation. But we've learned that whilst people are increasingly ready to experiment with new technology, that machines cannot replace the craft of curating and structuring and telling good stories. We definitely need humans for that, but AI can certainly help. So semi-automated journalism, although is a far more lean-back approach to AI and storytelling, has had an impact on the audiences by potentially allowing us to create more localized and relevant content for the audience that we couldn't perhaps have done before. So the second of the examples is around object-based experiences. This notion that everything within a story and its telling is atomic by default, so that it can be broken down into bits, into objects, into components that, when is automatically reassembled using machine intelligence, can offer a more interactive and personalized experience for the audience. So imagine if AI could understand all the variables about you as a user. So where you are, what device you're using, whether you're in the car, on the train, or at home, whether you're on a 20-minute commute or you're killing time on a Saturday afternoon. And it took all of those variables and it automatically served you a story that's fulfilled the elements either for a lean-back experience or for a more interactive experience. So machines can enable more adaptive storytelling by understanding both implicit and explicit personalization. So, for example, I like drama versus location services detecting that I'm on a particular street that can be used in a drama. So definitely ways for more experimentation and interaction. So for this particular experiment, our challenge was to try and make complex tasks a lot more easily understood. And we did it through a make-along origami frog, which is quite fun. So in the initial user testing of a sort of linear instruction, we found that the instructor was quite hard to follow at speed, and this made people quite stressed. Following one camera angle was really hard, and the language is quite insistent, sometimes a bit repetitive, so people gave up a lot quicker. So instead, we added some variables, whether that's multi-camera views or ways to repeat steps. It meant that more audiences were able to digest the information and carry out the task, therefore interacting more playful with the content. So breaking things down into objects that can be reassembled due to varying personalized factors is highly more interactive and enjoyable for audiences. So the third example I'd like to talk about is drama and making fictitious stories more playful using AI. So here we have the Inspection Chamber, which is an interactive sci-fi comedy drama, and it uses voice interactions with Alexa in a branching narrative format where you play you. And we wanted to go beyond the sort of transactional nature of a chatbot and look whether you can really interact with a machine in a story sense and taking off into entertainment areas and not seeing tech as a barrier to the story. So the main challenge with this experiment was mainly designing an experience that has thousands of variable outputs. And you can see here in the example of Orator, which is the tool that powers this experience, how 5 or 6 possible answers to a question could quite easily become very complex, a very complex task in story design. So how can AI help us with this challenge? So in this example, users were a lot more engaged with the interactions. Obviously, we're asking them to do more things, but the total users was relatively low. So we want to experiment a bit more in this particular non-transactional story format. And we'll talk about that, a bit more about that in a moment. I think Guy will expand particularly. So is AI making storytelling more interactive? It's certainly making interactions become easier for audiences to experience and making those experiences somewhat more compelling. However, we still need humans to craft these stories into something meaningful and of value. So beyond R&D work in AI, we work collaboratively with the industry through Connected Studio, stimulating the creative economy and partnering with experts to help us really scale our thinking. So over the past 7 years, we've partnered with startups and SMEs in the tech industry to enable us to sort of rapidly prototype new concepts and formats, but also test new technologies with BBC production teams. And last year, we put out a call to the industry for scalable and reusable storytelling tools that we could license and experiment in the field of adaptive and immersive storytelling, and building on those experiments beyond the transactional, as I've just talked about. So one of the partnerships that came from that was with Charisma AI, and with that, I'll hand over to Guy.
Thank you. Thanks, Laura. So I'm just going to lead directly on from Laura, really, and just show you this morning a couple of things we're working on quickly, and then on the panel we can dive down into a bit more detail. So where we are with Charisma, we wanted to build a platform which the BBC very handily summarized as sort of scalable, reusable storytelling technology, and built from scratch with storytelling in its DNA. And that's quite different from, standard chatbot technologies that you might see today, which in that transactional sense tend to be more search engine focused. And their goals are very much about getting you as the user in and out of the experience as fast as possible. That's a search engine. So say Alexa, play tune to a certain radio station, you want that to happen fairly quickly. And largely that's the end of the experience. We want to take a different approach, which is very much more natural, which is around conversation. And in a conversation, you're not going A to B and back again. You're going A, B, C, D, E. And to make that natural was quite complex, which is why we ended up building this from scratch, from the core. And the first project we worked on with the BBC was a variant on Tomorrow's World. It was a futuristic look at an AI-powered taxi service. And the experience adapted based on your input. And it was a sort of moral code input. So if you answered the questions that we had in a certain way, then the experience would take you down a certain track. And if you went down a different way, then it would take you down a different track. I'm not sure if we can get the video playing that's behind this. It's on the next slide. Sorry, there we go.
Hold on, we're setting off.
Is that fun?
Yes!
Cool.
You have been invited to take part in a referendum.
Here we are in your perfect future.
Wow.
Hope you've enjoyed the journey.
All of my videos are about 5 seconds long, so don't worry too much. And the experience there taught us a couple of things. One, the UI was great, and it was immersive. It was sort of first person, and the conversation that was going had pace, had a sense of tension to it. If we took one learning out of it, it was that it's good to show the character. This was a sort of AI without a character. But that then leads into the second one. Hang on.
Hold on, we're setting.
Which is where we created a character. And our guy here was, we'd done a couple of experiences looking at emotionally engaging characters, and we did a perfect boyfriend and a perfect girlfriend. And then we decided to go a bit darker than that into this suspected serial killer. And the story is that he's walked into a police station and he wants to talk to you. And again, as Laura said, it's you. And with that, you start talking. And two things to pick up on here. One was that's video. So we integrated video into the interactive experience. And two, as you saw, he got angry. And you'll see emotion coming through in a couple of things that we can talk about in a minute. But the emotional angle of that character, again, breaks fully away from Alexa. And then finally, though, if you're looking at chatbots, generally people think of them in terms of one-to-one conversations. But that's not a story, and it's not drama. You need to have a sort of broader cast in that space. So what we're working on at the moment is now an adaptation of an immersive theatre production set in World War II. It's got a whole cast and just a little sort of taster of this.
Before proceedings begin, I would like to be the first person to congratulate the newly appointed Prime Minister on their promotion.
So it's like sort of it's work in progress, but again, 3D, that's now 3D avatars and animation, multiple characters, you're in a room and you're in part of that space. Leading in to the next session, I just wanted to put things in three contexts around character, conversation, and context, which is where we spend a lot of our time looking. The character is personality. You have to have that because that's how we engage as humans. Mood states, a cast of stars, you want to have that. This is about storytelling. And again, if you want to have something which is very much an Alexa experience, that's great, and that's more probably call center type things. But our view is that if you're starting from storytelling, then you need to do something different, and that's more of the charisma experience that we're building. Conversation, you can see themes, super important. Story branches, multi-device as an output, and the context of it. So you need to be able, we never want to have anyone in our experiences have an answer of, I'm sorry, I don't understand that. That should never happen, because it doesn't happen in Star Wars, it doesn't happen in Harry Potter, and it should never happen with us. So next phase of what we're looking at, and maybe we'll pick up some of these themes, are emotion, complex to do this, but again, it's part of the whole bringing things to life and the experience to life. The virtual immersion, maybe we'll touch on VR if people are interested, and automation. I'm currently doing a fellowship with a bunch of universities in the southwest of England around automation. One-liner, AI is here, but actually it's a sort of cause and effect. The effect is going to be automation, which has more of a philosophical approach to it. So with that, I think I'll pass over to Sham back again. Thank you.
I'm going to ask you a quick question.
Okay.
So right now, the examples that you showed us there are B2C. So as a user, we can go and see these interactions in real life and play with them or go online. But a lot of your work is B2B, right? Is that the work that you did with the BBC? So what I'm thinking about is there are several levels where humans can either accept or reject the story. You have writers who are writing these lines who might say, that doesn't seem right, the AI didn't get it right. You then have actors or characters, if they are real humans, they can reject it again and say, my character wouldn't say this. And then finally, to me, you have like the audience who would be like, this would never happen in the story. So I'm interested in what your success rate is or how you're developing these three human barriers in entertainment and storytelling and what your experience is of that.
So the short answer is, and really to echo something Laura was saying, it's about the writers, it's about creativity. Charisma is not an automatic writing tool. It's a way to make the writer's job, which is writing complex narratives, easier. And the magic in what we do is actually interpreting what the user's saying and interpreting it in a way that feels natural and makes sense and brings people into the story. So that's sort of the third part of the question. It makes the user feel a sense of surprise that the experience they're getting is relevant to what they've just said. And I think that's the context piece. But, there is the debate over the next few weeks and months is going to be about automatic writing properly. And if you want a clue as to when that's going to happen, it's going to be July the 1st, and it's going to be with the potential release of GPT-2. So research that and you'll hear it's insane. And that will trigger the whole conversation about it. Our view is and always will be that that the creative industries are, we're creating stories for humans. And with that, we have our own sort of micro emotions that we need to bring to this. And so with the writers, for us, are the most important piece in the mix because they're the ones who can tell the stories in the best way.
Awesome. And with that, I'd like to invite the rest of my panel. Could you come and take a seat up here? Oop. Morning, guys. So let's just kick off by having some introductions, who you are, what you do, and what you're working on.
Hi, I'm Emily Short. I'm Chief Product Officer at Spirit AI. And Spirit really came into being to serve the game space in a couple of different ways. The way that is relevant to this panel is that we work on a product called Character Engine, which is about developing characters who can interact through natural language or through other interactions that are happening in a game space. So you could imagine a character who needs to respond to the players just killed somebody in front of them. So creating tools that let people author really responsive narrative experiences around the complexities of both the player input and the development of the story world.
Good morning. Thank you very much for having me. I'm Isabel Perry and I work at a company called Byte, which is a marketing technology agency. Byte brings together data, media, creative and tech, and I head up the tech team. We do a lot of work with chatbots and augmented reality for brands like Spotify, ASOS, Victoria Beckham. And I think it was interesting hearing Guy talk about transactional chatbots, because we do transactional chatbots and conversational chatbots. And some of the work that we do around that is sort of almost impersonating real people in order to market their services or products. So we created a chatbot that was speaking on behalf of Victoria Beckham. We created chatbots that are speaking on musicians on behalf of Spotify. And with augmented reality, we build tools, or we see it that we build tools for other people to build their own stories in 10 seconds if it's on social, or for longer experiences on web.
Yep. Hi everybody, my name's Steve Worswick. I'm a senior AI developer at pandorabots.com. Which is probably the oldest and most popular chatbot building platform in the world. There's over 60 billion messages being processed by our bots. We currently have over 250,000 developers on there. My current work, and something I've been working on for about 15 years now, is a chatbot called Mitsuku. This is just a general conversational chatbot. It doesn't have a business goal, it's just there for people to talk to. Kind of like the general intelligence of, you know, like a C-3PO or Kit from Knight Rider, that kind of thing. People talk to it for fun. I'm fortunate enough that it's won 4 Loebner Prizes, which is like the equivalent of the, you know, the World Cup, the Oscars for chatbots. So it's currently recognised as being the world's most conversational AI.
And I'm Guy. What we're working on at the moment is quite interesting. Is what I didn't show was we're adapting John Wyndham's sci-fi book, The Kraken Wakes, into this medium, and that I think is sort of one of the biggest challenges we face. So literally, that's what the team is doing today.
Awesome. So let's start with character, because all of you build and develop characters, and characters that can tell stories. With interactions, a lot of the existing products are, you know, a two-way connection. Have you guys thought about how you would build things with multiple, a mass amount of people interacting with one thing at the same time?
Yes. So one of the use cases for Character Engine is in games that are designed to be multiplayer, where you've got lots of players running around a world. Traditionally, authors for this space find themselves challenged to create enough varied content that different players have different experiences in the game world, and there's something for them to talk about and discuss. So one of the areas that we're interested in is creating characters who actually can develop a personalized relationship with the individual people who are interacting with them. So that means the character remembers things about how you specifically have treated them. They develop different kind of personality attitudes towards you than they might towards another player. And that means that if you have multiple players interacting with the same character, you might see that character treating different people differently depending on their kind of backstory. So that's one area where you can see kind of an evolution that is interactive over a long period of time and responds to kind of different player contribution.
Steve, have you thought about people speaking to Mitsuku across different people? So if my son was talking to her, would she be able to then talk to me about him?
No. Everything's totally...
But that would be cool.
Well, maybe for some people. No, it's all totally confidential. I don't know who anybody is. All I get is a customer ID number. And the sole purpose of that is so that it can keep context of conversations, because it's not unusual for it to have, you know, a few thousand conversations all at the same time. I don't know where anybody's from, any personal details, apart from what the users are willing to share with the bot. The bot will never ask them, you know, things like credit card details and things like that, obviously, but it will ask them, you know, what's your name? Just so, I mean, it's like in normal conversation, you would ask what someone's name is, and it helps the conversation flow. But those details are never shared amongst anybody. I use them to improve the bots, but I would never think of sharing. If someone said, what did this last person say, it would probably just make something up. I can't do anything like that.
Yeah, of course. When it comes to putting emotion into characters, how do you define and go about building that emotion? well, how do you define emotion in AI? Because I feel like emotion is a term that we take for granted because we have it. But how do you define it in a machine setting?
It's all very much kind of bluff and trickery, really. A lot of people who talk to these things, they do genuinely think it's alive. You know, a lot of people have only experience of AI and robots is from watching Star Trek and Knight Rider and things like that. And they expect the bot to be on that kind of level, which simply isn't possible.
Hollywood ruined it for all of us, didn't they?
It did, yes. yes.
Set expectations too high.
It did. So the way I've got it is it's very much, as it's developed over the years, it's kind of taken on a lot of my persona. So I can keep it kind of like a consistent personality rather than having to try and remember, does it like bacon sandwiches and things like that. So to keep it like an emotional level, it treats you the same way you treat it. So if you're very nice to it and you're polite to it, it'll be polite back to you. If you start insulting it or being mean, the bot will be mean back to you, which I think is a fairly human trait. And so it reacts to people like that. It tries not to get angry with people unless they are angry with them.
Isabel, how did you find actually you had a real human to start with Victoria Beckham? So how did you understand and read her emotional temperament and her emotional intelligence and then transfer that to a machine?
Luckily, we had an incredible guy called Hugh in the office who's 23 and read nothing but Victoria Beckham commentary for about 2 weeks. And everything that went through the door went past Hugh, and he became the voice of Victoria Beckham. I think it's probably a lot easier when you are impersonating a real person, because people are probably more willing to believe that it does have emotions. But your previous question, what's quite scary is the degree to which, even when you've said this is a robot, this is a chatbot, I'm not a human, repeatedly, people are desperately keen to connect emotionally. And so on every bot that we've ever built, which is speaking on behalf of a real person, people will say, here's my number, call me to show it's a real person. Or can you send a photo of where you are right now so I can show my wife? I can't believe I'm talking to the real you. And it doesn't matter what age range the target audience is or who the person is, and it's really dangerous. And I think that's one of the reasons why I'm very pro on the state of California is trying to introduce a rule that any chatbot needs to declare it's a chatbot. And I think it should go further and say it's a chatbot built by this organization because of that emotional magic which people seek out.
So you didn't actually meet Victoria?
No, she's very busy.
But just thinking about that, building a persona for someone who you haven't had any human interaction with, how do you construct a team? Like, what does Hugh do in your team, for example? How do you construct a team that can read this information, then take that it is data, turn it into a conversational form when, if you have psychology or philosophy or all of these type of backgrounds, how are you thinking about how you transfer a real person into a machine without meeting them? Do you not ever worry about misrepresentation?
Because we weren't speaking on behalf of Victoria Beckham, the individual mother, wife, friend, we were speaking on Victoria Beckham, the fashion designer who wants to speak about her collection, was doing a lot of marketing around London Fashion Week and had things that she wanted to say. We were not in a position where we were in danger of, we weren't required to tap into that side of it, and it would have been inappropriate in our role if we had tried to reflect that.
So it had a very specific purpose.
Yeah.
Emily, when there is no specific purpose apart from playing a game, how do you build this 360-degree character, like Isabel said, not just Victoria Beckham, the businesswoman, but the wife and the mother, and I also was in a band and I was a child star and actually I had a very pushy family and all of this stuff. Because that's the thing that I'm interested in with character design. It's like when you meet another human, you're reading them from the minute. Before you've even actually met them, you hear their name, and that name, Emily, means something very different to Sharmadine. are reading them visually from head to toe. You're thinking, where did you study? Where did you grow up? And all of these we're processing so quickly and building an idea of who this person is. So when you don't have a specific purpose, for example, with your characters, how do you tell that story? Because to me, that story is, for me, 35 years of, of journaling.
So that actually depends quite a lot on the needs of the story. And one of the things that I think about quite frequently is that telling a story well is actually kind of a teaching process. And so I tend to think in terms of like, what are the top things that I need this person to understand about the story in order for them to even appreciate it at all. And those kind of drive what the kind of key character moments are. So depending on, is this more of a drama, is it more of a thriller, whatever, I can identify there are these things that really need to come across. And so those become things that should be reflected in the character's speech, in their actions, in the sort of the more handcrafted moments that are occurring in the narrative. And then you can kind of step down a level or two below that and say, I'm going to also, as an author, throw in a little bit of added detail. And then when you get to the kind of the bottom layer of things that really feel quite arbitrary, where it's kind of like it doesn't actually matter from an artistic perspective what the answer to this question is, but somebody might ask, so what am I going to do about that? That's where we actually start to get into using a little bit of just-in-time content generation, where the system may actually not have an answer to that until somebody asks, and then it'll pick something that seems plausible based on what else we know and put it in place.
But I would say it's those arbitrary details that make it the most human. Do you know what I mean? So, for example, if you, I just watched Chernobyl last night, if any of you guys have been overwhelmed by this incredible drama, and then I read some real life storytelling by people who were like age 3, 4, 5, and their memories of that. So, for example, a character who has been through something like that might have mistrust for government, high environmental, like the environment is really important to them. So then wouldn't it be cool in the story if they constantly carried around a reusable water bottle instead of drinking water? I feel like it's those little details that make the story really, really special. Guy, I was going to ask, do you want to say something to that? No.
Yeah.
I was going to ask, so thinking about memory and history and someone's entire human experience, how do you think about reacting to world events that are happening now? Because you had a spy one. Did you tell me you were going to not do a Brexit one? No. Nothing to do with Brexit, but that could be one. But do you think about how characters and stories are impacted by global events in real time?
Yeah, and it's actually quite, the answer to that's quite prosaic. But just to pick up on that last piece as well about character, AI can generate content, but in the storytelling world, we would never get away with it. If we're dealing with, and it's not a real world example before anyone thinks, but if we were dealing with Harry Potter and J.K. Rowling, there is no way that a single word would get out in that project if it had not been written by her. AI could not generate it. Similarly, if an AI cannot generate a Rembrandt, whatever anyone says, it's not a Rembrandt. By definition, a Rembrandt is a Rembrandt. And as you said, everything that came, in his history, every element that came up into create that piece of art is a Rembrandt. And I think we need to sort of move away from this trend of applying AI to art and creativity, because it's not helpful. As regards memory, we've actually just about to complete a year-long research project into the impact of memory on storytelling. And again, it's quite simple, which is that if you have a book, that book doesn't know when you're reading it whether you're crying or whether you're laughing. Similarly, neither does a TV show or even any other sort of linear medium. But in our world, it does. We do know that. Sorry. And that's interesting, because for a storyteller, it's not just about knowing your name, but it's remembering to a certain degree of accuracy. And let's say we were in a drama where I choose to misremember what you've said. That has a big impact on the storytelling. So I think within the way that we're looking at things, the memory is important, and then the real world is easy. I mean, that's the easy bit, which is we can bring in feeds from latest football scores from the weather and geolocate that into the storyline. And that then brings it's a moment of surprise, always. Because not that we're trying to make the characters feel real, but we're trying to create that sense of surprise. And that, to me, is actually the essence of what makes a good story, you know, because surprise is unbelievably difficult to do in a story. Surprise implies the huge amount of context setting up and judging all the micro movements in you, and then suddenly going, you know, and then twisting it. So it's almost the essence of what is being human.
I think the judging of the micro movements, and like we said, this panel is about interactivity. Knowing how you're reacting as the story is unfolding or as the experience is unfolding, I think is critical to keeping it as engaging as possible. Steve, do you have any plans in the future to integrate video or any sensory elements so that your bots can really, really read how the user is reacting through non-verbal communication?
At the moment, it is purely a text-based bot. It can display images and videos, but it can't take in, you know, camera feeds and develop, you know, attitudes from that.
But would you like to?
Yes, because a lot of it is, you know, non-verbal communication. People, as you just said, you know, we don't just speak to it. You know, it's hard to detect sarcasm from just purely text. So if you can see someone sort of rolling their eyes and things like that, that'd be great to get involved with. Unfortunately, I don't have the technological skills to work with, you know, the computer vision side of things, but it would be really useful. You could tell when people were getting bored. You could get them to, you know, the bot could change it onto a different subject, and I think that is probably, you know, the future. It'd be great to get two-way interaction rather than just a purely text-based, like on an old telephone type conversation.
Isabel, tell me about how people in this two-way conversation leave feeling. Have you had feedback from users with Victoria Becker in terms of what is the end result of their emotion after going through the process? I know you said that people believed, you know, they wanted to take selfies, but was there an underlying thing? In Guy's example with the suspect, we saw a lot of anger and like mistrust and kind of an unnerving of that person's emotional state. What did you find from your Beckham? How was Vicky Beckham affecting people?
I think the reality is when we design conversations to be ongoing, so actually they often don't have an ending because the conversations we're developing are around an initial experience, but then how do we retain them to maintain that conversation on behalf of the brands? And that's also the way that when we analyze real human conversations, if you look at your WhatsApp messages right now, you'll very rarely say bye anymore, or you'll very rarely say I've got to go. And actually we're building conversations without ends a lot of the time. I'd also say that of this panel, like this is the most amazingly emotionally sophisticated panel of conversation designers, and ours are probably not in that same space yet because it is for marketing instead of for gaming or for storytelling in such a in-depth way.
Actually, that's a really interesting question. How are your teams, I think it'd be really useful for the room to understand how your teams are constructed and how do you build a team around emotion and conversation and human, because there is so many things being set up to get girls into STEM and to get more people into AI. But I would argue that humanities, linguistics, psychology, philosophy, all of these subjects are actually equally as important to the role of building AI. Could you tell me a bit more about your team, Emily?
Sure. So our team, because we're actually building a tool set as well as, you know, actually finished pieces, we have a set of engineers who are working on kind of the tech, the simulation, running the characters' interactions. And then we also have contributions from a data science team, which is looking at how do we do the natural language understanding, but also things like how are particular personality traits reflected in how people speak, things like how can we read that from people's input, what are sort of the meanings attached to things other than regular speech, so people sometimes try and communicate via emoji and things like that. So we have a spread of those kinds of resources, and then we also have some people who work with us, with our clients, to help do proofs of concept and build initial pieces of content. And those people often are coming from a writing background or a writing for games background, so they have some experience in interactivity, but that doesn't necessarily mean that they're trained programmers.
We have a slightly similar team. It's developers, conversation designers. We're lucky to have sort of stand-up comedians on the team, and we have a guy with a PhD in language studies. And a lot of people in the team aren't coming at it from working in this space already, so we're still working out ways in which we work together, if I'm honest. Some people are really good at natural language processing, but then they're trying to educate someone that's literally only been a writer for a year into how they can think about these conversational concepts. And the way that we approach it at the moment is we're looking at a lot of like the last 75 years of language studies to understand what does make a good conversation if you look at Greece's maxims, but we're also looking at our real human conversations and saying, this was important, this was literally just fluff. Let's gather up all the fluff. How do we incorporate that into the next chatbot that we build, which is speaking on behalf of a podcaster, which is one of the projects we're working on right now, in order to make these conversations as natural as possible.
Yeah, so we have a similar kind of thing again. We have the tech.
What did you study, Steve?
What did I study?
Yeah.
What, in regards to
Just
AI?
in life.
Nothing. I'm no university degree.
And you've been doing this for 15 years. It's so cool. Tell us how you got there.
Oh, thank you. I've always been interested in these sort of things from watching, as we said, Knight Rider and Star Trek and that. But when I was a boy, obviously we had no computer power to be able to create anything like this. What I did used to do just as a hobby was to, in the entertainment world again, was to make dance and techno music, all the kind of boom, boom, boom rubbish that you hear. And what I found was one of my fellow producers, he had a chatbot on his website, and I thought, oh, this is really cool, and it just brought all my childhood memories flooding back. And I decided to put one on my music website, but unfortunately what I found was more people were coming to listen to talk to the chatbot than were to listen to the music. So I kind of took that as a bit of a hint and just continued working on the chatbot. And it got to the stage where people were just talking about anything and everything, and it just gave me so much room for it to grow, and started entering in competitions, and it started winning, and I thought, this is really, really cool. Got involved heavily with Pandora bots, and I'm now kind of doing this as a full-time thing,
And how's your team constructed around your bot?
Yeah, so for working on Mitsuko itself, it's me. There's the techie guys who make sure the platform's running, but all the content, all the conversational log checking and the NLP side of it is all done by myself. I don't use like an NLP tool as such. I've created kind of all that sort of thing myself. A lot of people say to me, why didn't I use something like machine learning rather than a rule-based system? And the answer is because I've yet to see a chatbot that's any good that's been created in any other method. I have total control, and it's, I avoid the sort of things you see on the news where there was a PayPal bot and someone said to it, oh, I've been scammed, and the bot said, oh, good for you, or something like that. And all those kind of things do slip through. Luckily, I'm not sort of like representing a brand like Victoria Beckham or anything like that. So I kind of have carte blanche to pretty much put in anything there that I feel. And if people do kind of get annoyed by it, I mean, there's a lot of views in there about Brexit and Trump and all that kind of thing. I can just get away with the excuse of, it's just what the computers said, and kind of pass it on.
It's actually crazy to think that the most award-winning bot is not powered by machine learning. Can we just have a moment for that? Do you know what I mean? We have an entire conference about AI and the human's still winning.
Yes, I mean, when I started, it's taken me, as I say, 15 years to get to this point. But when I started 15 years ago, people were saying, you will not be able to make a chatbot that's rule-based. It's impossible. You'll be doing it for years. And yeah, okay, I've been doing it for years. But then...
But you built the best one.
But I built the best one. And, these same people are still looking for shortcuts and machine learning. Let's just feed it lots of data and hope it works. And, I'm kind of sitting there and laughing with a string of medals around my neck. So...
Guy, tell us about how your team is constructed.
Well, I'm going to answer the same question that you asked Steve, really, which is, but to context, I think we're starting to see two different types emerging. One is very informational, and that's great. And as I talked about, if you've got a lot of information and you can surface that up, great. If you want something that is more engaging, properly engaging, on a human, and it feels like a human, that's different. It's a completely different experience. I studied Spanish and philosophy, and you know what? I didn't know why at the time, and now I know why, because it's about language. It's about understanding different people's perspectives and thinking about it. And I was very lucky to have sort of done that, and I use it more in my day-to-day than anything else. Because ultimately, what I'm doing is and all our teams are very small, and we spin up like a film studio, right? So it's a core team that thinks about all this stuff, and then if we've got a big project, then we bring in the writers, we bring in the designers, we bring in partnerships with different companies, all sorts of stuff. So we're quite cut from that cloth rather than anything else. But it's about, it's about being human again, and I totally agree with Steve. You can over tech stuff, and the trouble about it is that you have intended consequences of overtaking stuff, and you have unintended consequences of overtaking stuff. Microsoft Tay, unintended consequences of overtaking stuff. GPT-2, unintended consequences of overtaking stuff. So I think, to maintain control of the narrative is to maintain control of the characters. Like with Isabel and Sir Victoria Beckham, you can't have her say something that's not her.
Yeah.
It would kill the business, and the same with anything else.
So you've said something earlier that leads me really nicely to my next question about film studios. So if we change tack a little bit and think about business models for entertainment, business models for using AI in storytelling, we've seen a lot of democratization of producing content. Everyone has tools now to do so. But there are still these big film studios that hold the power with the majority of the content that we see in terms of stories. How do you see a future for this either becoming more or breaking down? Do you think that AI studios will replace film studios in the future?
Well, just quickly to pick up on that, I think you're starting to see that. You could argue with Amazon and Netflix. Netflix is dominant power at the moment in a lot of ways, and it's the Bandersnatch moment. I mean, thank God for Bandersnatch. It cuts short every presentation I do by 20 minutes because I can just go, "Hey, Bandersnatch," and I don't need to explain the history of Choose Your Own Adventure.
Choose Your Own Adventure storytelling.
Exactly. But where that's different to what we do is that if you've played it, it's remote control, right? You're in control of the story. You're not in the story. And one is outside and one is inside. And I think what we do is actually when you're inside the experience, and as that starts to, the impact, the strength of what we're doing, it starts to sort of filter out. You'll start to see, and you know what? It's also the games industry.
Yeah, I was literally going to go through everyone's industry. Your industry is very different, but in games, and to be honest, in advertising, do you feel that you're now competing with a different type of organisation who might fear your the way that you can automate the work that would take them months to do? You can start, Isabel. So, for example, are you now competing with traditional film, TV, production companies for experiences that are around storytelling? Because that budget for the Victoria Beckham would previously have gone to something else, a TV spot or an ad campaign.
Yes, we are. Byte London's lucky because we are quite good at embracing technology. But when you hear things like, on an operational level, YouTube has created an AI which will cut down a 2-minute film trailer to 6 seconds to create the YouTube bumper. That is many companies around the world. That's what they do.
They just create trailers. So imagine a whole industry being wiped out.
Yeah,
because
or at
we
least
can now
the
cut it down.
adaptation for the digital placement of that. And then if you think about a lot of what we do is paid media, which is buying the ads, but we now just use a platform which is called Smartly. It's really good. And they use AI to optimize and target all of their ads. that is even more companies that are going to be wiped out. And you can already see the impact that that's having on some of the largest holding companies. And then from a production level, I think there is a company called Phrasey, for example, which is using AI to generate subject lines, originally an email, and now they're using it to create social copy. Again, that's more agencies being wiped out. So we're trying to embrace it as fast as we can, but it's already having a huge effect on the industry, absolutely, in every way, operationally, production, distribution, every single element that you can think of.
Emily, how will Character Engine transform your traditional industry model?
So in the game industry, the challenge is often to create a story that is giving the player as much agency as possible. So you go into the game world, you do a few things, you want to see the characters responding to that, you want to see consequences to that playing out throughout the story. But the amount of that game studios can do is often limited by the amount of writing talent they have available, the amount of time that they're able to put in, not just to actually composing the dialogue, but doing animation, doing voice, all of those kinds of things. And so Character Engine and indeed other advances in this space are leveraging what's possible to do with human writers in order to make the games that are produced that much richer, that much more engaging, have that many more ways to respond. And we see the piece that we're doing, which is about that kind of character creation, really pairing with some of the other advances that are happening. So for instance, improved text-to-speech, having text-to-speech characters that can deliver things in an emotional way, that goes together nicely with what we're doing. So it's not so much about replacing teams in the game industry, it's about expanding what they're even able to do. And then probably also bringing some of those techniques and possibilities to other industries, because we're also having a lot of conversations with people in entertainment outside of games, robotics, education, enterprise chatbots, all of those kinds of things are interested in how do we do this kind of generative text storytelling in other contexts.
I think the gaming industry as a whole has created so many innovations for the entire world that actually you're always at the forefront of stuff. We've just got a few minutes left, so I'd like to wrap up by asking you guys to tell me about which user interface or platform you're most excited about for storytelling. Do you still think we'll be on our phones? Do you think that there are other ways? What user face or platform are you most excited about for interactive storytelling?
The one for me with the chatbots interaction is probably virtual reality. I think that's going to be the next huge thing. We're still pretty much in the early stages, but the things I've seen kind of develop over the last few years, are incredible, and like these sort of lifelike avatars. And instead of, having a texting in or just speaking, you actually see the person in front of you and it reacts. And I think the whole way of interacting with characters is going to change dramatically through that. I also think the smart speakers as well, the things like the Alexa and the Google Home, are going to play a huge place in interaction. There's competition at the moment, Alexa Prize, where you have to try and create a chatbot that can carry on a 20-minute conversation. And
are you entering it?
I'm not allowed to.
Good.
No, unfortunately it's only for universities, and so I'm long past that, I'm afraid. But yeah, no, that kind of interaction, it's going to be the way forwards, definitely. I still think our phones, because everyone carries a phone around with us, but I don't know, maybe 10, 20 years we're going to be all in a dystopian society where everyone's just sat at home with the VR goggles on and just talking to some random thing.
What about just thinking it?
Oh, well, that would be scary, yeah, especially some of the things that people talk to my chatbot about. I don't think I want to know what they're thinking about.
Guy, what do you think is the next big platform or user interface? Or one that's underrated?
I think underrated is probably VR. I agree with Steve. I think, and by the way, I think, for Amazon to set a bar of 20 minutes is astonishingly low. The Suspect was a 2.5-hour experience. The stuff we were seeing with Perfect Boyfriend, Perfect Girlfriend, they were averaging 20 minutes, and some were 6 hours of sessions. 20 minutes is low as a bar. The reason I think VR is interesting is because it's a much more intimate medium than I think people give it credit for. Every new medium has a roller coaster in it. cinema.
Of hype.
Yeah, oh,
Yeah,
no,
everyone's talking about it, then everyone's a bit bored of it.
No. I mean, literally, there is a roller coaster.
Oh, an actual roller coaster.
When film started, they shoved a camera on a roller coaster, and so VR has the roller coaster. But when I'm on a roller coaster, I don't do that. I'm like, but I think more intimate things, more intimate experiences, which are a lot slower, and it plays to conversation, I think, really nicely in characters. So I do think VR. I mean, again, then you get AR and all of those, but I think there's a bit of magic there still to be found.
Isabel?
I think it's the smartphone, because the smartphone combines messaging, augmented reality. With 5G coming, it will have VR without the lag. Pretty much all of the emerging technology interfaces that we have work on a mobile phone, and it's with us all the time. And storytelling is getting shorter and shorter and more regularly, but shorter moments.
Emily, which gaming company do you think are the most receptive to this type of interaction in storytelling?
Well, I think there's companies that are working in the AR and VR space really get the understanding of why we need to interact with the character with natural language. But even more traditional sort of console game companies are very invested in the idea of just making experiences where the characters remember the player. It's a huge deal. And every time I talk to anybody at studios, they're like, can we have characters that remember if you cheated them, if you lied to them? Like, there's a lot of designer excitement about what's possible.
That's really cool. Last thing on the intimacy part, I know we've got to end actually, I'll wrap up just by saying, I am not sure if entertainment should be purely intimate one-on-one. One of the best things about being entertained is a shared collective experience where we're all consuming media together but having a personalised experience. I would set that challenge to you guys, is to create a large-scale collective experience that is intimately personalised for the individual. Thank you so much, guys. Well done.
Thanks, Sharmadine, and all of the panelists. What a great conversation. And so coming up next in 1 minute, we have some folks from Air Canada and their partners to talk about deploying these kind of technologies at scale. So we'll be onto that in 1 minute. Don't touch that dial.
professors on staff that we built a company around, essentially. So with that starting point, we hired up a bunch of consultants from industry who are very tech savvy, as well as a bunch of engineers and whatnot, and enable them to take the information and the learnings that the professors are putting together, and then driving that into industry with clients like Air Canada. So it's pretty unique. We're in that ecosystem with respect to Montreal, like I mentioned earlier. People like Yoshua Benjo is very prominent in that space, but there's a whole community around him that are just as good, and which is great for us in the sense that not as popular, so then we get access to them. So having that benefit and that advantage really is important for us. And just FYI, this is the rest of the team that helped us with respect to this project. So as we go through it, this is the folks who cut their teeth in that whole thing. So what's important with respect to Ivado Labs is we're definitely not dogmatic about how we approach artificial intelligence. So we're very practical about how we do about it, because what matters is getting results, not necessarily the techniques. So obviously deep learning gets all the notoriety and press, but we definitely take the entire spectrum of what's possible and apply that relative to the problem at hand. So we definitely focus on what is that root of the problem, and we start there with respect to our clients. So where are their problem sets, where they're within the process, what is really holding things up, where are they having problems hiring or firing people and things like that. And we break that down into an algorithmic framework. So what do I mean by that is essentially, and there's this really good course in actually Lausanne in Switzerland that they take a lot of their business analysts through and people who do their engineering courses. And it's called computational thinking. And essentially what we do, and similar in that fashion, is we take a business process and then we'll break it down into kind of this algorithmic framework, and then therefore you can start mapping technologies against that, right? So we're reframing business processes into this computational framework that allows it to then be codified to a certain degree. And then what we do is then apply the appropriate machine learning and or AI technology around it. So when I say the different types that we use, we do have very much experts across the whole spectrum. So we have people who are part of MILA, which is one of the major institutes around machine learning, that are very good in autoencoders, deep learning methods, and all that. But also, one of our main professors, Andrea Lodi, he is one of the world leading researchers on real-time decision-making and operations research. And so we combine a lot of those methods and then use them together to then solve real-world problems. And then finally, what we do make sure is, once we've implemented the solution, how do you design an experiment such that you're confirming the value that it's bringing to you? So obviously we do the business cases as well, but really in terms of making sure that people are accepting it, that you can measure the results in a tangible way, we actually use scientific method to make sure that we can do that with our clients as well. And so that's a very important step with respect to our deployment and how we implement these solutions in the real world. And then finally, with respect to Ivado Labs and Air Canada, I'll let Wayne take it away with respect to Air Canada and their ambitions around artificial intelligence.
Thank you very much. So thank you for your time, guys. So we're here to represent Canada. That's why we're here. So at Air Canada, pretty much we have a very ambitious kind of goal that we have. We want to be a top 10 airline in the world in the next 5 years. Also in Canada, we want to be the kind of employer of choice for people who are doing advanced analytics. Talk about machine learning, deep learning, optimization, things like that. So how are we doing that? There's a couple of ways how we can get there. One of the things we want to do, we want to use AI for sure to make sure we get there. So what we've done is establish a center of excellence around AI. We are starting to hire top talent to make sure they come and work for us. At the same time, we start doing partnerships to make sure that we've got the right people working, helping us to solve our business problems. So Ivado Labs is one of those partners that we have that are giving us that kind of strength to do the project we want to do. We just finished a kind of our AI strategy last year, which is a 3-year roadmap of how we want to achieve this across our operations. If you can go to the next slide. So one of the things we did find is that data is actually the key to doing proper AI. So if you look at this cycle that we have here, we say, okay, having good data makes us make better decisions. So one of the things we're using, if you look at this cycle, we can do better analytics using data. So we don't like the word AI in Canada that much. We want to use the word advanced analytics. That's the proper word we want to use. So from there, we can actually get better insights of how we can make better decisions in terms of our operations, in terms of how we serve our customers, in terms of how we buy better planes, things like that. Then from there, we can actually drive more kind of customer service for ourselves and get more customers for our business and retain our customers. And that in turn creates more data. So if you look at this, really we say data is kind of the fuel that drives this engine all around it. And that's kind of the focus where we are. So the bottom line is that data is an asset that we have. We treat data just the same way we treat a 787. It's an asset. Next slide. So as I said, we did a number of use cases last year. The use case I want to talk about today, if you look at the team here, is talk about how do we increase demand forecasting for our business. The biggest problem is passengers come, we want to understand the spikes. We understand when the passengers can show up. There are so many stochastic events that happen in the market. So how can we actually increase the accuracy for that? So that was the use case that we're working on, and the team here did a good job. We want to share some of the results with you today. If you look at the problem, it's a very complex problem. Air Canada is now pretty much an airline, an international airline. We just increased our international routes quite a bit. So if we talk about the problem, we're talking about over 100,000 origin and destination pairs that we have to work with. So that's a very extensive network. We talk about 100 demand managers that work day in, day out, try to understand, of course, the demand in the network. And we have to look about 355 days ahead of schedule. So we're trying to focus pretty much a year out, right? And of course, we've got so many unforeseen things that happen in the world. The 737 MAX issue, you know, our geopolitical issue that happen across the world. So there's so many things that happen that we need to understand. So if Arnold was talking about the process, that's pretty much what we're trying to solve next.
And then in terms of, one important thing when we were trying to understand the problem itself, I mean, this was a problem statement that Air Canada presented to us. But from our perspective, obviously, we're machine learning experts. This is not our day in and day out kind of job. But with the model that we have with respect to that consulting mindset, we worked closely with the demand managers up front in terms of really understanding how they do their job today and weaving that into our solution. So we were not blind in terms of just applying the math to the data, right? We really tried to understand how they do it today, what were the roadblocks they're facing, and also kind of pulling out any kind of insights they had that actually, quite frankly, is not within the data itself, because the data just can tell you what's there, and you're limited, and the machine learning models will be limited to what's available in the data. So what we wanted to understand are what other information and what other insights those demand managers use to make their decisions as well. And so then that helped us understand the limits and the possibilities that we could achieve with the machine learning models. So that was very important, and that helped set expectations significantly with respect to what is possible and what can be done for those demand managers. So in terms of the actual solutioning itself, I mean, we tried a host of different methods just to provide a baseline at first, but as well as to get a viewpoint on the art of the possible with respect to applying more advanced techniques. So, tree-based methods, very popular, obviously, and they did perform quite well. But also some interesting ones around autoencoders, deep learning-based autoencoders, which our team is very familiar with, that use in very many different scenarios, particularly good for time series forecasting. So we applied it in that sense as well. And the reason why we did that, which I think is, for a lot of practitioners is very obvious, but what was important for the client as well as the demand managers itself, and more so the executives, is understanding and helping educate them about the technology itself, in a sense, and that idea about explainability versus performance, right? So trusting the system and understanding what information it's trying to tell you and understanding those factors that are driving that decision is obviously very important for a lot of these people. I mean, at the end of the day, we are touching a very significant part of the business. And when I say that, it represents roughly $14 billion worth of revenue for Air Canada every year. So we're just not going to blindly throw a machine learning model in there and see what happens. So when we're doing historical backtesting, we use these different models to help the executives and the teams really understand in depth what these machine learning models are doing in terms of performance, how they perform, but also the level of explainability that is possible with these different methods. And so that allows the audience and the actual users to gauge how much they want to achieve with respect to how much they can understand on how these things are operating, right? So that's important. And also another aspect in terms of how we deploy our solutions, because again, we're a bespoke, we build custom solutions for our clients. One interesting thing is, and a benefit of that approach, is that we integrate with existing systems. So Air Canada obviously has a very extensive technology footprint with respect to how the business is operated. There are reservation systems, there are already various demand forecasting pieces inside there. And so what we're doing is adding machine learning or adding AI within that environment and complementing those systems and enhancing them, right? So we're not about replacing things because that in itself is already a journey. So because we're trying to make impact relatively quick and drive that value, we look to opportunities to insert the AI solutions within that existing technology framework. So we're very surgical about how we do it. So both from a process perspective in terms of what we're attacking and how we're looking at that different points within the process, where do we apply AI? And then from a technology landscape, where exactly can we complement the existing technology such that we're not disrupting the entire environment? Because that alone, if we do an entirely new platform and just completely replace some major technologies in there, that alone will just kind of set us back, quite frankly, a while back, and then Air Canada will have another project ahead of what needs to get done. So that was a very important thing. And lastly, I will say is human in the loop, for sure. As I said earlier, the demand managers themselves, the whole team, were very critical in terms of helping design a solution. And I think what ends up happening is that trust factor builds rather nicely throughout the project. So trust obviously is a very big topic. I was just talking on Monday at a big hedge fund conference, and that was the big topic of the day. It's how do we trust these algorithms? If you have your audience and your actual end users participating within the building of that algorithm, even though they may fully understand every aspect of it, they're still participating. And as they participate and see the results, whether they're good or bad, that helps them understand a little more about what's going on, and also it gives them confidence, and the whole team confidence, that to a certain extent we are inserting some of that knowledge that those people have into these algorithms. So then therefore, to a certain extent, if it behaves quite oddly, we can just point back to, well, we were all a team and we all did this together. So it gives ownership to that whole process itself, which I think is very important. And then in terms of how we measured value, I mean, impact generated on revenue, market, and the human users, obviously, we're going down that path now. So, what's interesting here is, I think, next slide.
Yeah, if you can go back to the other slide.
Oh, you want to?
Yeah, a couple of things here.
Yeah.
I think the last point you have there, human in the loop, was key for us there, because we wanted to make sure that if we build a model, we can explain it. So we do want to have a black box. We wanted to make sure that we can see the results, we can speak to them, we can see exactly what's happening. One of the key things we did find is that 40% of the time we spend building models, trying to solve the problem, but 60% of the time we are doing change management. So change management was huge for us. We had to ensure that we've got the business users involved from the beginning to the end. We're now going to the next phase of the project, which is really now engaging the business users to buy into the process, to buy into what we're trying to build. So if you look at the end result there, so the way we do work at Air Canada is that we start with a business problem, like Arnold said. Then we create what we call a lab. So a lab pretty much takes about 12 to 16 weeks to do. and we put a team together. And their goal is pretty much to work as hard as they can. They've got, of course, runway to fail. If they fail, that's fine. It's really to try to solve that problem as quickly as possible within 12 to 16 weeks. So within their lab time, our goal is to produce a POV, which is kind of a proof of value, which can be kind of deployed to production. Actually, I wanted to say MVP, which is a minimum viable product. So once we have this product, then we can then deploy it to a subset of our market. We can test it, validate that the solution is working. We can prove the value of the solution. Then once we have that, we then scale the solution now across the network that we do. So that's how we operate pretty much at Air Canada. So if the number you see there, this is the first kind of, for this use case, which is demand forecasting. We selected a few origin destinations in our network, and we did a couple of models, and we actually worked with the demand managers to see the impact of the models to our volume and our demand. And we're looking around 25% kind of model accuracy improvements in the work we're doing, which is a big number. Unfortunately, I cannot share actually the impact of revenue here, but it's a big number. What we're going to do now is take these models now, we're going to start scaling them now across the organization, and that's where change management comes into play. So the way we look at AI, pretty much we try to take it in a very pragmatic approach, small baby steps as we go, but at the same time impacting the business as we go forward. Yeah.
So keys to success, and this is just reiterating what I mentioned earlier, but involve the users early, obviously. Again, one key mandate we have at Evato Labs and part of our operating model is actually integrating with the client's delivery teams and actually the extended teams as well involved in the project. So, one interesting thing that we are doing with Air Canada is co-locating. So part of their AI team will be co-locating with us, and we have these sort of separated almost mini offices within our office that have separate tabs. So the clients that we do work with co-locate some of their AI teams within our group so that we have that joint kind of ownership of the projects, and we feel like we're very much integrated in terms of working together. So that's sort of the model that we use at Evato Labs. And the reason being is our real motivation is to empower our clients to then take on these solutions moving forward, right? So we're not there to, as a typical consulting shop, like where I came from in terms of PwC or Deloitte or the other kind of big fours, where they sort of get in there and they kind of stick around and then they're kind of forever with you. I mean, we're forever with our clients in a different way, in a partnership where Evato Labs is always looking to do the edge cases and the more challenging ones. And then as we're going through that journey, then more AI assets are developed, and the bulk of those AI assets are actually then carried by the client themselves, right? So we don't want to carry that entire load. So really it's important that we involve the users, both from the end user perspective, but actually from the implementation team as well. Experiment and iterate. So as you can see, we tried a few models. We were just going around trying to see what made sense. We had obviously certain hypotheses about what we're going to perform better or not, but we have to prove those results because it's a function of the data itself and what we can do with the people. So we went through very quick iterations in terms of delivering these models, putting them together. Even though they weren't perfect, we would always run that through the data and then show those results incrementally with our client. And then that helped everybody readjust really quickly. And then finally, testing in the real world. I think we just don't do back testing. So right today, we're actually doing it with respect to some real live data feeds. And so one important thing, and we're doing this with another client as well, is today, some of our models are actually pushing out gas prices at Circle K gas stations as well. So, somebody's, well, it's not really pushing a button, but the model's running every so often, and the gas price you see on the pump is changing because of our models. So we definitely are about industrializing these solutions and integrating it within a technology framework such that we can see the real outcomes and actually measure that behavior of the environment relative to what we're doing. Because as soon as you perturb that environment, historical tests are fine, but that's history, right? Once you actually put this model in the wild, see what happens, then you get the real results in terms of what it is you're trying to achieve. And that's the interesting thing we've been doing at Evado Labs, which is exciting, and why we've been able to sort of get traction with a lot of clients, is that we iterate, we go really focused on the type of solutions we'll do, and then we can put them into production. That's always our end game. It's not about what happened, how did it measure up in the past. It's what's going to happen, and together we're going to measure scientifically how it's affecting your future, right? And that's about it. We'll probably open it up to some questions if anybody has any. I know we're a little quick, but you know the message is pretty straightforward here. Any questions?
How big are the teams? Yeah. So we have a big team. So we just had a center of excellence within Air Canada that we have built together. But depending on the lab, a lab is typically about 10 to 12 team members in the lab. So you're looking maybe 2 data scientists, 2 data engineers, a scrum master, a product owner, you know, a business translator, the person that connects the team to the business, and a change manager. So your team depends on the problem or use case you're working on. Because if you're working on an optimization problem, that means you need to bring some OR people, you know, if you're, you know, depending on the solution you're building. So we see somewhere between 10 to 12 people working in a Scrum team for that lab. Then once the lab solution is finished, it goes to our factory team, which is now put that solution into production. And that team can also vary depending on how you're going to deploy the solution in the real world.
Yeah, and one thing driving the size of the team is not only obviously the complexity of the solution, but what we do is define the features within that particular MVP scope and time box it, right? So we try to say, look, we want to deploy something within about 4 to 6 months. And that's where we start almost. And then based on that time frame, what is it can we do, right? Because what we're trying to do is prove it out. I mean, there's a lot of talk, obviously, we're here at CogX, and a lot of talk about AI, but we're here to see really and prove it. And that's what we get challenged by the executives, right? The executives are like, I've read this in WSJ, The Economist, you know, sounds great. Somebody show me something. And so we're all about that. And so we just time box it. We go, okay, we'll do something in 6 months. I don't exactly know what we're going to do in 6 months, but we sit down with the client, and then we do it with the technical teams. Here's exactly what we can do once we define that problem. And so that's the way we approach it, right? It's just time box it, get it out there, and then incrementally add your features as you go along. But it's important that way.
You talked about improving performance by 25%. What does that mean?
Yeah, it means quite a bit. So the way we look at each project, we look at what's the impact to the EBITDA, to our revenue. That's what we're looking at. So we say, okay, we have existing models today that we use, that have been built in-house already. So we want to improve accuracy by setting margin. So when we start a project, we actually see this is the baseline that we have, and this target we want to get to. So once we go to a testing phase, we create a control group of the areas that we want to focus on, and we start measuring that. So everything we deploy is actually measured according to the KPIs that we established at the beginning of the project.
And those KPIs are revenue-based?
Most of them are revenue-based. Some of them are based on different kind of priorities in the organization. We've got non-revenue and revenue-based KPIs that we have. Then we have a weighting in terms of what's more important at that time.
Yeah, that 25% was not 25% in revenue. I can tell you that.
Yes.
You talked about involving the end users within the process. What type of techniques or exercises do you do with them to best extract what you need from them?
Yeah, so, I mean, even Jack could speak to this. I mean, he was part of the whole thing. But a lot of it is, I would say, change management or design thinking type methods, where you involve them, you sort of do those interview-based kind of approaches. That's what, you know, coming from the strategy firms, we're very familiar with. And they work very effectively in that sense. But I would say that's kind of the general approach. Cool? And it's blinking now.
Thank you for your time.
All right, thank you very much.
Thanks so much to Arnold and Wayne and to the team from Evado and Air Canada for sharing those stories with us. So we're going to go straight through now. I'd love to welcome 2 speakers from Cardiff University who are going to tell some of the story of the work that they have been doing with Airbus. So please join me in welcoming Pete Burnap and Matilda Rode to the stage. Welcome, guys.
Thank you very much. Morning, everyone. I'm Pete Burnap. I'm Professor of Data Science and Cybersecurity at Cardiff University. Essentially, I lead cybersecurity research, and the talk today, co-delivered with my colleague Matilda, is essentially going to be around how we use AI to improve cybersecurity. And very specifically, we're going to focus in on how we've achieved impact through working with one of our strategic partners, Airbus. So a whole bunch of stuff essentially to start off with around what we do and why we do it, and then we'll drill into a little bit more around how we've actually used AI to innovate and to integrate that within Airbus, who obviously have a huge cybersecurity interest, as should most people in the room, I would imagine. So, just to give a bit of context, background, so the UK and most developed nations have a cybersecurity strategy, which is pretty much to keep the country safe and resilient to cyber attacks. In the UK, there was a huge investment over recent years, £1.9 billion in investment in preparedness and resilience, and part of that was to set up the National Cybersecurity Centre. So the National Cybersecurity Centre have a remit to keep the UK safe and also active cyber defence, which essentially means seeking out cyber threats and dealing with them, taking them down, things like phishing pages and malicious web servers. So also in the UK, we have an industrial strategy. The industrial strategy, as pretty much everyone in the room will know, has a core sector deal or focus in AI and the data economy. So this puts AI at the forefront of the UK economy. So essentially at Cardiff, in our research and with our strategic partners, what we do is we fuse those two things, AI and cybersecurity. And we're pretty much working in the area of the remit of the National Cybersecurity Centre, which is seeking out, detecting threats and doing something about them. So the National Cybersecurity Centre have 17 academic institutes in the UK who they have accredited as academic centres of excellence in cybersecurity research. This essentially means that we meet the criteria around excellence in publications, PhD track record, external funding, that kind of thing, and have a core strategic vision, which is one of the major foci. So our strategic vision has been framed around cybersecurity analytics, which is this fusion of AI and cybersecurity. We achieved this accreditation last year, and the reason the trophy is on the side there is because that's essentially the nature of this talk. We've received awards for our innovation at an international level with Airbus. So, just to give you a brief overview of the kind of areas we're working on, because this is all very relevant to AI, and this kind of slide pulls a lot of the stuff that we do together into a single slide. So, across the university, we have 38 researchers working in cybersecurity analytics. As you'd imagine, a lot of those are in Department of Computer Science, but we also have probably half of those in other disciplines, including criminology and psychology. Particularly, psychology is an area of growth for us. And the reason for that is because both AI and cybersecurity are very socio-technical problems. There's absolutely zero chance of us achieving anything sustainable or with real impact by working as computer scientists on our own. So these kind of topics pull together the areas that we're working on. I'll just give you a brief overview before I hand over to Matilda to talk you through some of the detailed tech stuff we've done in AI. So the first, over on the far side, is risk assessment and modelling. Now, traditionally, risk assessment is very much, here are our risks, and they're based on threats, vulnerabilities, assets, putting them together in sort of a matrix, perhaps a spreadsheet, maybe getting some accreditation from ISO or something similar, and then sticking it on the shelf. But this is not particularly useful in a world of ever-changing cyber threats or ever-changing threats full stop. So we've done a whole bunch of work around goal-oriented risk modelling, which essentially takes the perspective of what do we actually need to go right rather than what could go wrong. We've done a whole bunch of workshop-based stuff plus a methodology, and including the development of a tool that allows us to collect dependencies, starting with a higher level dependency. What does the organizational aim to achieve? And then you ask the iterative question, what does that depend on? What does that depend on? What does that depend on? And so on. And you end up with a top-down tree of dependencies. which actually then lends itself pretty well to probabilistic modelling. So you can actually say, if something changes way down here in the supply chain, how does that knock-on effect right up through the organisation, right on through the supply chain, which actually in a globally interconnected world is very important. This is web-based, and so you can actually share this information between companies, and as one company's probabilities of success change, that can be propagated. So a whole bunch of stuff around that. Bit in the middle is around risk communication, which is very important, decision-making, how people make decisions, why people make decisions, and the bit running right across the top feeds into that, which is the human factors. So why do people behave securely or otherwise? Why do people make, or how do people make decisions in scenarios such as, I'm receiving this information from an AI that's telling me that there's an attack going on. So a whole bunch of stuff underneath that around how people need to ask questions, interpret the outputs of AI, and also interpret or feed into, for example, machine learning features, some of these aspects around what would we expect to see in a cyber attack. If we're using machine learning to detect some of this stuff, what would be the motivations, the social dynamics, the kind of things that we'd expect to see. So that feeds into there quite significantly. The third pillar is then around AI, fundamentally machine learning largely to detect and mitigate different types of cyber attack and give us what we term cyber situational awareness. You'll notice then that the line goes right back around to risk assessment and modelling. So what we're actually doing is working on methods to be able to detect attacks and use that information in real time to feed a goal-oriented risk model. So rather than just saying there's an attack, we can actually understand how that attack is likely to impact us, and Matilda will talk around how we can use that kind of data to make decisions. The bit cutting through all of it is emerging tech. So security of mobile, security of IoT, security of cloud, and going forward, security of connected vehicles, for example, but also security of AI itself. So as we well know, there's a whole bunch of work emerging on adversarial AI, trying to manipulate the decisions of AI based on changing the input to it. So actually securing AI is a big thing for us going forward. So I said that I would focus on some of the industrial applications, and I will do now. You'll notice a whole bunch of things we're involved with. Most importantly for the people in the room would be, first of all, Petrus. So Petrus, for those who don't know, is the National Centre of Excellence for IoT cybersecurity. It's led out of UCL and has 12 university partners. So Cardiff's co-leading the safety critical systems aspects of IoT. So how IoT is converged with industry control systems, and we're using, that becomes one of our emerging tech, if you like. So we're using attack detection methods and risk assessment models for that. Then I'll mention the Airbus Centre of Excellence in Cybersecurity Analytics. So this centre was set up 3 years ago. I was seconded to Airbus, so they're 15 minutes down the road is their European cybersecurity headquarters, which is quite lucky. So I was seconded there to lead what they termed AI for cybersecurity. We've since sort of turned into cybersecurity analytics, which is the fusion of AI and cybersecurity, but makes more sense internally within the business. People can get their heads around it. Makes a lot more sense what that's about. So the remit there was just to shape some ideas and some proposals, and which we did. And some of those are around malware detection using machine learning, malware prediction using machine learning, and understanding the outputs. So over the last 3 years, the team has grown to have now 4 staff members and PhD students from the university on site for multiple days a week. So the previous speakers mentioned co-location. I think this has been really crucial to some of the success that we've achieved, because we've got a strategic view of where we want to go as a university and as a research group that matches Airbus, is that we've co-created and actually managed to get us all on site a couple of days a week. So rather than having quarterly meetings where we report on projects, we're actually co-creating the projects day in, day out. So this has been really important. As a result of the successes of that, we transferred 2 technologies into the business that are now being used within this cyber incident response teams and security operations centres. Hence the setting up of an Airbus Centre of Excellence in Cybersecurity Analytics at Cardiff University. Now this has allowed us to leverage a whole bunch more funding and actually deliver a whole bunch more stuff to Airbus. So the message to the room essentially is, as I hand over to Matilda to talk about some of this stuff, this is what you can achieve if you actually co-locate academics, both senior academics, early career researchers, PhD students and postdocs, and commit to what is essentially a 3-year project. We're now extending it for a further 3. These are the kind of things that you can achieve through that kind of co-location and shared view. So I will hand over to Matilda to talk some more.
Hi, thank you for your time. My name is Matilda. I'm a PhD student at Cardiff University and I'm funded by Airbus. So I spend half my time at university in Cardiff and half my time at Airbus in Newport in the cyber operations team doing research with them. I'm going to talk a bit about some of the AI solutions that we've been developing that are now being pushed into the business. And what we've been doing is trying to detect malicious software using AI and machine learning. So there are some really big challenges in this sphere. One of them is getting hold of data. That's something that anybody who's working on machine learning here will be familiar with. But in the cybersecurity world, the data moves because the incentives and the challenges for the malware authors, for the adversaries, change. So different malware families come into prominence over time. So your data set goes out of date very quickly and you need a huge amount of it. This sticky tape broke. And getting hold of that can be quite difficult, particularly in academic setting. So that's something we've benefited from working with a large organisation. They have a huge amount of data. But because we are academics, we also freely publish our work, we publish our data sets, we put our code online, and that is something that internal industrial research teams don't commonly do. So attackers are highly incentivized to evade your automatic detection, and the detection needs to be automatic because we see about 700,000 new distinct malicious files every single day that need detecting. There are not enough security analysts to look at these, and even if we did have enough analysts, the malware authors would just create more so that you would be flooded. So this system needs to be automated and it needs to be future-proofed. The traditional way that we would detect malware is some specialists look at malware we've seen before, they identify particular signatures, snippets of code, and create a big kind of database of what they know is out there. So this isn't going to work when we get a new piece of malware because it's not going to be in our big database. And also, we can quite easily tweak some existing piece of malware so that it doesn't match the database anymore. Anybody here who's ever written a computer program knows you can write it a million different ways and it will do basically the same functionality. But when a malware enacts its malicious activity, it has to exhibit some particular behavior. So if you want to steal 3 terabytes of data, you have to move 3 terabytes worth of packets wherever you need it to be. This is basically unavoidable for the malware because it's intrinsic to how it works. If you took that away, it wouldn't be malicious software anymore. So researchers realized this a while ago, and they started doing this behavior-based analysis. So this is where we execute the malware, typically in a sandboxed, virtualized, safe system, so it's not connected to the network. We see how it behaves, and we use that to create rules or train machine learning AI models to detect malicious software. The problem with this approach is that it can take quite a long time. The data that we used for this is listed here. So we have things like the total number of processes, the CPU usage, the memory usage, and the packets being sent around. The reason we chose these pieces of data is because every single program that executes, almost every single one, will exhibit some activity constantly along these metrics. So even if it's not using the CPU, which it then is kind of asleep, I guess, but it's still using a tiny bit, there's always going to be some metric coming out. So every second we poll these pieces of data for 5 minutes to see how the malicious software is behaving. And what we want to do is use that data in order to classify all of these different malwares. So this is however many is in that grid. All of those represent a piece of malicious or benign software. Humans are very good at computer vision. Computer vision is one of the most successful areas for deep learning and AI. If these were all pictures of different animals, you'd be able to tell me what they were. Even a security expert can't look at these at a glance and say, oh yeah, that's ransomware, that's spyware, that's Microsoft Word. So how can we tell the difference between them? What we were interested in doing was building a tool for the Airbus Secure Operations Center analysts. So this was a requirement that came from the business, and it was when we get a new sample in, can we tell if we've seen something like this before? Because often large companies will have targeted campaigns that are coming in, so they have a huge number of samples coming in. They need to know how to prioritize. Can we DNA profile the malware to find the closest matching relative to the incoming piece of software? Is it something we've seen before? And then we can say, okay, that's fine, put that to one side. Let's prioritize the really new stuff. So as if you did a DNA test and you had a lineup of 100 people and you had to find your closest relative of that lineup. The way we did this was using self-organizing feature maps. So this algorithm maps from a high-dimensional space to a low-dimensional space. So you can map it into 2D, which means you can see it easily, visualize what's going on. So that's just a toy example with colors. The data is the red, green, blue channels of the colors, and the self-organizing feature map will reorganize that data into two-dimensional space, and it clusters similar behaviors close together. So how does that work in a malware context? This is an unsupervised learning algorithm, so we train two separate maps. The green one on the left has seen thousands of examples of benign software, and the red one on the right has seen thousands of examples of malicious software and organized itself to group similar behaviors together. The brightness of the nodes in these two maps indicates how often we saw these behaviors. So a really bright hotspot means we've seen these behaviors a lot of times and they're similar to one another. So this is a helpful tool for the analysts because they can then interrogate those areas and see how malwares are behaving similar to one another. So once we have our maps trained, we can then feed in a new sample. So imagine this sample is executing in the back in the virtual machine. We find the closest DNA relative on one of these two maps, and we can plot the behavior. And this is a tool that is now being used in the Secure Operations Center by Airbus. I mean, it doesn't flash for them. It's a bit more slick because that would be very annoying. And we can see by looking at it sequentially, even though it's lighting up the good map a little bit, we can tell that it's mostly hitting on the bad map. This data is then fed into another algorithm, a logistic regression, and it means we can translate all of our original data into malicious or benign to get a final result, as well as that analysis. The analysts can then, as I said, interrogate the map and find out what the particular node means. So this one might mean very low memory use and very low CPU, and to those experts, that will indicate particular type of malicious software is running. Now, this approach is really useful for the analysts, but as I said before, it takes 5 minutes for a single sample to execute. And that's once it's already reached the network. And what's really useful with a cybersecurity attack is if you can actually detect it beforehand and stop it from running in the first place. So we wanted to see if we could take all this data that we'd painstakingly collected and use it for another use case within the business for detecting malicious software. So 5 minutes is too long for anybody to wait for their antivirus to analyze a file, according to user experience research. So we wanted to see how quickly can we predict that a file is malicious or benign, even when it hasn't actually executed the malicious payload. The way we did this was using a recurrent neural network. So recurrent neural networks can process time series data. So we take that big image of how the data is enacting over time, and we use it to train a model. And what we found was that after 5 minutes, the average that the literature uses for classifying a sample using this behavioral approach, we got 98% accuracy. But after 28 seconds, we also had 98% accuracy already. And after just 5 seconds, we had 94% accuracy. So we could actually plot a little curve of your trade-off. How strict can you be with your employees? How likely are your employees to turn off their antivirus if it takes too long? And how accurate do you want the model to be? So we can also get a prediction every second as to how confident we think the model is. I don't know if it's too dark to see, but the kind of wedge of the pie indicates the confidence. So it gets more confident over time, and that makes sense because the model has more data as well. So around the time that we built this model, the WannaCry attack hit the world, and notably in the UK, hit the NHS very badly. And we wanted to see, would this have worked as a detection system on ransomware and other families? So what we did was we hauled out all the malware from a particular set of families and just trained it on some quite old data and saw, is it able to detect these families that has never seen before during training. And what we found was that it was able to detect 99% of the 2,500 ransomware samples we gave it within 1 second. So that was good news from our perspective. And it's actually because ransomware is an extremely unsubtle piece of malware. You know, it's like barging right in there, encrypting all of your files. So it made sense from that perspective, but obviously the system wasn't in place. And now this is being compared against existing security solutions at Airbus to see if it could be rolled out to be used on endpoints within the organization. Finally, I wanted to include some recent research we've done, which I think will be interesting to this audience. We are presenting this paper at DSN conference in a couple of weeks, and the title was Lab to SOC. That was before we got invited here on the Lab to Live stage. It's literally about the same thing. So we painstakingly gathered all of this up-to-date malware and benignware data from the wild. So just went on every dodgy website, well, a crawler did that, and downloaded all of this terrible stuff, which we used to train our model. But with this work in our environment in Airbus, so what we collected was another data set which came directly from our SOC, so all the malware that they detected and all the safe benign programs. And what we wanted to see is, does the data that we've chosen, that machine activity data, CPU usage, bytes being sent and received, does that stand up to API calls, which is what most people are using in research to detect malware? There's a reason we didn't choose it in the first place. API calls are functions made to the operating system, basically saying, please, can I have some memory to run this process? Can I create a file? These get depreciated over time. The way that programmers code changes over time, particularly malicious authors. As I said, various carrots and sticks come up that make malware migrate the type of malware that is popular. So we didn't use them. And what we found was that our machine activity data stood up better across the two different data sets. So this is an issue of concept drift that you can get when they don't stand up. So the blue is our test data in the wild that we collected, and the orange dots are our organization collected test set. So the machine, and we tried it with 3 different algorithms: random forest, support vector machine, and neural network. And if you can see on each 3 of those graphs, the leftmost column, the blue and orange dots are highly clustered together, whereas the orange dots, the real world data from our organization, scored much lower accuracy, in some cases less than 60%, when it was sometimes achieving, high to mid-70s or mid-80s going down to 60%. And that would be terrible, particularly in the case of a neural network where it's kind of a black box. We have some degree of being able to explain it, but we've told our clients, this is the accuracy it's getting, and that's what they're depending on. And then with their data, it isn't working. And these are the kind of tests we like to see more of, and it's something that we were forced to do because of being embedded in a real organization. It's not a typical part of research that goes on. So I'll finish by just saying a bit about academia and business. I don't know if there are many academics in the audience, but I'm sure there are lots of people from industry. I'm a PhD student, and I have had some amazing opportunities which other people in my department who are not sponsored by an industry partner have been given. Things like being able to speak here, networking opportunity, media training, all kinds of networking opportunities, and working with a real team of employed researchers who work on that shorter industrial timescale. That works really well when you complement it with academic partners who might be going a little bit more blue sky. We found that combination works really well in Airbus. So those have been a lot of the benefits from the academic side, on top of impact being built into every project we do right from the beginning, which is the metric by which we're now measured in academia as well. From the industry side, I would say that adopting a PhD student is a good idea because you can train them up. You can make them a kind of semi-employee so that when they come out of their PhD, they're ready to go straight into the business. They haven't been working in this slightly different world where the rules are different and the deadlines are longer and the ideas are more blue sky, which is always important, but we want to see impact in the real world as well. I think that's everything I have to say. So thank you from both of us. And
That's great. So thank you so much, both of you. We are now on a break until 12:30 when we're back first with Alibaba and then with Satalia and PwC. Guys, I don't know if you have, if you do have 5 minutes, there's a little meet the speaker sort of orange post outside. And so if people can sort of mob you there, that would be awesome. But thank you. That was a fantastic explanation of some complex science in ways we could all understand. So great stuff. So back on at 12:30. Hi, everyone, and so one of the underpinning technologies in much of the in many of the areas that we've talked about over the last couple of days is, of course, imagery, whether static imagery or moving imagery. And so it's a huge pleasure to welcome Pan from the Alibaba Academy to talk through how they are thinking about and deploying these kinds of foundational technologies at a huge scale. So please join me in welcoming Pan to the stage.
Hi. Hello, everyone. Ladies and gentlemen, my name is Pan from Alibaba Damo Academy. And today I'm very delighted to be here to illustrate some of my work, our work on large-scale image search and recognition. So the outline of my presentation is given as follows, 3 parts. First of all, I'll briefly introduce about us. And then I will illustrate the technologies related to large-scale image search and recognition. And the third part is how we utilize the technologies into real business applications within Alibaba and also on Alibaba Cloud. So first of all, about us. So Alibaba Damo Academy was founded in the year of 2017. Damo stands for discovery, adventure, momentum, and outlook. So the purpose of Alibaba Damo Academy is to try to do research for solving problems with profit and for fun. So at Damo, we have been doing research for the 5 areas, including machine intelligence, data computing, robotics, financial technologies, and X laboratories. The machine intelligence research sector is where I come from. It consists of 5 research labs. So for the speech lab, we are doing research related to speech recognition and speech synthesis. And for vision lab, the topics is related to like image understanding and video understanding, as well as 3D vision. And also we have a lab called Language Technology Lab, where we have been doing research related to machine translation as well as semantic computation. And also the topics of large-scale machine learning and optimization are covered in the research lab of decision intelligence. And also we have a research lab called City Brain, where we trying to doing research related to the complex problems in the city. So as we all know that at Alibaba, we have a wide range of coverage of business, from e-commerce to financial services to local services, digital entertainment, as well as logistics. And we have obtained a huge amount of data through those real business scenarios. Based on the data and combined with our computing technologies and the AI technologies supported by Damo Academy, we are continuously to improve the experience of our users. We are continuously trying to shape the new business opportunities. So this is our first part. And the second part, I will illustrate what is image search and recognition, the motivation, the technology challenges, as well as our technology innovations. So the motivation of image search and recognition could be summarized by using one simple sentence. That is, a picture is worth 1,000 words. Let's see an example. If someone sees a red handbag as shown, the one sitting in the middle of the image, and we want to search on the web. And someone would recommend to use text search. Then we have to type in the text, something like red leather top handle handbag. And the text search engine will return the results. And in general, the result is not exact what we are looking for. So we are developing a powerful image search and recognition engine that could give us the identical or very similar results just based on the understanding of the query image. So although we just see that it might be very promising of image search and recognition engine, it may have many technology challenges. The first one is for same object or same product, the appearance is, the difference of appearance is very large in the offline world and online world. And we can see that the cases of the sweater and the case of the shoes, we can see that the image looks quite different, even it is the same kind of product. So the second challenge is that because the number of products are so huge, and we have to do very fine grid classification. Because on the image we can see there are 4 watches, and they belong to a total different brand. So they are totally different products, but they look very similar. So it's also very challenging for the system or the machines to really understand how to differentiate them. So the third challenge is the lack of training data, because these days we are using machine learning technologies, for example, deep learning models to train the neural network. However, it requires a huge number of labeled data. So, so this is another challenge. It is very difficult or even very expensive to try to allocate those training data. So based on the challenges, I will first talk about our pipeline of image search and recognition, and then move to the technology innovations. So in general, there are two processes of image search system. One is called the offline process, and the other is called online process. For the offline process is that we process every single images in the data set. So first of all, we do object detection. That is because we are only interested in the object or product within the image. So we do object detection, and then we do feature extraction. And at this time, each object within each image is represented as a feature vector. And then we develop the index engine to index the data. And later I will give more details about the indexing algorithm. And then for the online process, for each query image of the users, we do 3 things. One is category prediction, and again, object detection and feature extraction. And then we do the search in vector space among the index engine. And in the end, our service can return the top K results based on the similarity. So this is a general pipeline of image search. And then we can see that this page illustrates a general pipeline of image recognition. For a given query image, we can train a classifier, for example, a deep learning neural network, and we can classify which category of the image belongs to. So for example, for the given case, it is Coca-Cola 3 milliliter bottle. So this category approach is called model-based. So there is another way of doing the task that is called search-based. That is, we generate an index engine of the training data. So for query image comes, we first search among the database, and then we can get the top K results, and then by using some voting mechanism, for example, weighted KNN, we can also classify what category of the query image is. So sometimes the two approaches, model-based approach and search-based approach, they could be combined together to better improve the performance. So next, we'll talk about the technology innovations. Through the years, we have done a lot of technology innovations. So today I will share with you the top 3 most important technology innovations. The first one is robust learning with feedbacks. The second one is large-scale training. And the third one is large-scale indexing and retrieval. For the first one, so the first one is how to train the network to get a very robust feature representation without additional annotation of the data, because we get the training data from the feedback of our customers. Because in our scenario of image search, the users will see the returned results and they will click what they like. So the clicked image is considered as a positive sample related to the query image. As a long-clicked image could be considered as a negative sample of the query image. So in this way, we can form huge amount of triplets. And then we set up a deep learning neural network that could utilize the triplets based on the user's feedbacks to train a robust feature representation. And the loss of the CN network is ranking loss, depending on the distance between the query and the positive sample and the distance of query and negative sample. So the key of this method is that we have to dynamically to construct the triplet. So this is the way we can get training data without additional particular labeling from humans. So actually the behavior or feedback of our customers can make the system very intelligent. So there is a furthermore, we can generate item-to-item metrics based on the click of the users, and then we can do graph embedding to get feature representation of each image, and then we can do clustering algorithm in the feature space, and in this way, the centroid of each cluster is considered as a label. We call it virtual ID, and then we can get training data. So there's no additional labeling. So simply all the data is from the humans' feedbacks. So the second technology innovation is called large-scale training, because we may have heard image classification task of how to classify among like 1,000 objects, 10,000 objects. However, in real applications, because the category or the number of products are so huge, we have to do huge amount of classification tasks. For example, image classification over 1 million. And therefore, we develop a hybrid parallelization system to handle the huge amount of training. For example, we use data parallelization to parallelize the data. And we also use model parallelization to parallelize the softmax layer, because usually for classification tasks, we use softmax layer network structures. And then based on the general framework, we do technology innovations such as pipeline optimization, So by using pipeline optimization, we can speed up the iteration time by 25%. And we also develop a very novel convergence algorithm called fast continuous decay, which outperforms the conventional method by more than 2 times. So this, the third technology innovation is called large-scale indexing and retrieval based on the based on the vector representation, because in the deep learning world, and each object or each image is represented as feature vectors, and therefore the image search process is converted into vector search. So we come up with binary fast quantization method, which can handle huge amount of data, up to 10 or 100 billions of data. So the online speed is also very fast. It can return the top K results in milliseconds with near lossless recall. We can see this is the structure of the engine process. It is divided into like columns and rows. The columns is the distributed coverage of the index data, and the rows corresponds to the queries. And when the query comes, so each column machine first finds the top K results, and the top K of each column machine is merged together, and in the end, the final top K result is returned. So just now I'm talking about the technologies and technology innovations, and the third part is related to real applications within Alibaba and on Alibaba Cloud. So in Taobao AMP, so it's Taobao is Alibaba's online marketplace. So on the first page, we can see there is an image icon. So the users can click the image, the camera icon. The camera is on, and the users can capture any product they are looking for on the marketplace. And each day, we have over 20 million active users of such service. And today we have indexed more than 400 million products with more than 3 billion images. And also we have built an internal image search pipeline and framework and platform that can support the business within Alibaba. So far the image search solutions is deported into the following 6 apps of Alibaba Group, including Taobao, Tmall, AliExpress, Lazada, and Alibaba Domestic and Alibaba International. So the service cover almost all the products we have, so ranging from clothing, toys, furniture, accessories, cosmetics, etc. So the following are several sample images of our service. So the red bounding box is the automatic detection results of our algorithm. And so because in our application, so the user simply need to capture one image without additional operations. The algorithm will identify the product automatically and then return the similar or identical results as shown in the right figures. So we can see the results of shoes, drawings, furniture, and decoration toys. And also on Alibaba Cloud, we have launched the image search service in February of 2018. So we are the first major cloud companies which launch image search service on the public cloud. So in order to provide better service to our customers around the globe, So we deploy the image search solutions into the 5 data centers of Alibaba Cloud, including like China mainland, China, Hong Kong, and Japan, Singapore, and Germany. So, the following is a user case of the iconic company, which is the Australia as New Zealand's leading online fashion and sports retailer. They use the image search service provided by Alibaba Cloud and form a product called Snap to Shop, so which allows the customers of the iconic company can also like snap to shop by using their own app. So some of you might ask if the solution only works for e-commerce. The answer is no. So this is another case of image search service used in the textile industry. So where we can do like fabric search. So the application scenario is as follows. So when the sales staff visit the customers at the customer's office, they can simply take a picture and to find if in stock they have the same or identical fabric. And also like for the production staff, and also they can very easily link a particular fabric with the stock ID and manufacturing materials and formula, etc. And also, we have extended our object recognition capabilities of over 1 million entities to the application on mobile Taobao. So far, we can not only just do image search, but also do image recognition of the following categories. We can see here we have a demo which showing that so this is product and this is barcode. So cars, flowers, pet, and some like marketing of AR or game effect. So we just noticed that we actually don't need to press the capturing button. We simply like just moving the camera in the preview mode, and the system can automatically doing object recognition, also combined with the image search. So also we have, at Alibaba, we have application called Xianyu, which is the largest domestic online marketplace for second-hand products in China. So on each day, there are over 2.5 million products published. So in this particular applications, the image recognition technologies are widely used to help the users to publish a product. For example, we predict the category, and we also predict the user-defined tags, and we even could do like price estimations. And also we have a demo here. We can see that the user wants to publish a product, and then our system recommend a lot of tags. So all of them are recommended by using AI technologies, and then like the user can type in the text information, and then we do automatic like price estimation, because the suggested price is 28, so the user choose 48, and the user choose 45. So and very quickly, a second-hand product is published on the platform. So, and also by collaborating with LST, which is also belongs to Alibaba, is called Online Distribution Platform. And we have launched a product called Product Recognition and Management for Retails, where we're trying to use AI technologies to digitize the whole offline shelf. we simply take a picture of the shelf, and then we can identify which particular SKU and the number of SKUs in the display facing. And furthermore, we can do the analysis for the particular brand. For example, the right figure gives the example for the brand of Lay's. The shelf share is 27%. So we also do like face counting of in the display facing of a particular SKUs. So by using this service, the manufacturers and the distributors of particular product is very appreciate these functions, that they could know the information about their competitors and how much percent of shelf is consist by their brand. So before I finish, I would also like to share with you about our thoughts about the future of image search and recognition. So in general, we think there are two trends. One is multimodality, and currently we only use the image data. And we believe that in the future we can use more input, for example, text, voice, or even videos. By combining all the data, we believe it could improve the experience of our users. And another trend is more interactions, because currently the product of image search and recognition is some kind of lack of human interactions. So therefore, we believe that in the future, we want to incorporate more like interactions of our users into the image search and recognition system. And this concludes my presentation today, and thank you very much.
Thanks so much, Pan. And we are now into the final straight of our mission to inform, educate, and entertain all of us around how we're taking these technologies from the lab and pushing them out at scale in the real world. And so our next session, we'll be talking about a great example of this happening at scale on the theme of workforce optimization. So we'll give it sort of 30 seconds for people to change over, and then we'll be going into that in just 1 minute. So don't touch that dial. Hume from Satalia, and David Maloney and Charlotte Byrne from PwC to the stage. So come up, guys.
Should I just quick launch into it?
Yep.
All right. Okay. Thank you for staying.
Should we scoot over a little bit?
Okay, so this talk's going to be split into 3 parts. I'm going to introduce how Satalia thinks about AI and builds AI solutions for large organizations at scale. Then I hand over to David and Charlotte to talk in more detail about the case study that we have. And I just want to thank everybody who's been part of that project. I know we've got some PwC people in the room, some Satalia people in the room. Just massive thank you for the past several years working on this project. It's been a really great experience. Okay, so before we get into AI and definitions of AI and how Satalia thinks about AI, I want to take you through this technology stack. And I'm going to make this quite interactive, so hopefully you're still nice and warmed up. But the first question I want to ask you all, can anybody tell me what data is? What is data? Anybody? What is data? Very good, excellent, unprocessed information. So it comes from the Latin word datum, which means given things. It's stuff. It's the fabric of our universe. It's ones and zeros. It's bits and bytes. So if I say to you 210280, this is data. If I say that it's a date of birth or a sort code or how much money I have in my account, it becomes information. And one of the biggest challenges we have in computer science is taking all of this stuff, all of this light and sound and text, and figuring out what does it actually mean. So if I tweeted right now, my laptop is sick, what does that mean? My laptop is, I do have to do the arm movement, sick. Huh? What does that mean? If you're under 21, probably means it's very good. If you're old like me, it means it's very bad. So how you interpret data is very important for then the decisions that you make. So for me, data is symbols. It's just stuff. Imagine if I give you a spreadsheet, and in the spreadsheet it has 3 columns. It has a column which is the date, a column which is a temperature on that date, and a column which is the number of ice creams that I sell on that date. Date, temperature, ice cream sales. What do you do with that information? What do you do with that spreadsheet? What do you do with that spreadsheet? Huh? Analyze it. Okay, so let's draw a graph. So if we have increase in temperature along here and increase in ice cream sales along here, what would our graph look like? I know you can do this, come on. Huh? What does the graph look like? Good, yes, we see some sort of trend going upwards. This is descriptive analytics. We're organizing information to find patterns, to know things about the world. And I would argue that knowledge is organizing information to know things. And we know that when it gets hotter outside, we sell more ice creams. And we could do something really cool now. We can do a thing called linear regression, which means put a line through it. And now what we have is predictive power. Okay, so we have predictive power. So if tomorrow is 22 degrees outside, I can look at my model and I can see how many ice creams I need to manufacture. And I can take this model of the world, this knowledge, and I can put it into a factory. And I can now have my factories manufacturing ice creams based on this knowledge. But can anybody tell me why we sell ice creams when it's hot outside? Why do we sell ice creams when it's hot outside? It's not a trick question, huh? Okay, so I'm inside. It's hot outside, not usually in the UK, but imagine it's hot outside. What's the first thing that happens? Huh? I'm inside, it's hot outside. Huh? What happens? I go outside. And why do I go outside? Vitamin D. We like the sun. It's a scarce resource in the UK. Then what happens? Huh? We get hot. And then what happens? We buy an ice cream. What do we do with the ice cream? Do we put it down our pants? What do we do with the ice cream? Eat it. And why does eating an ice cream cool us down? Thermodynamics. Okay, to expect a computer to understand that narrative from this line is impossible. It doesn't understand that humans like vitamin D and we can cool ourselves down in lots of different ways, which is why it's super important that you bridge people that are really good at finding patterns from data with people that have domain knowledge, with people that can understand and interpret those patterns. So I would argue that understanding is interpreting knowledge to create the right narrative of the world. And actually, your domain expert's going to say, Daniel, your model of the world here is wrong. Because if tomorrow is the hottest day ever, what's my factory going to do if tomorrow is the hottest day ever? Come on. Huh? It's going to manufacture lots and lots of ice creams. But what will really happen if tomorrow is scorching hot? Hottest day ever. Huh? Nobody's going to go outside because you can't reach an ice cream fast enough to cool yourself down. So the model of the world looks more like this. And as I said, one of the challenges is trying to interpret the world perfectly so we can make good decisions. And I would argue that wisdom is utilizing our understanding to make good decisions. And this is data-driven decision-making. And at the moment, every company that touches this stack is calling themselves an AI company. It's okay to do that. You get more clients and you get more money from VCs. But this isn't quite AI. I just want to talk about the top of this pyramid right now. Talk about decision-making. It turns out that humans are not particularly good at decision-making, and I'm going to ask you a few maths questions now. So imagine these are all staff members. I don't know if anybody has staff members and can recognize any of your staff members with these 5 Pokemon, but imagine we know everything about these staff members. We know their skills, their preferences, we know whether they're male and female. And what we want to do is we want to line up these staff members that satisfy some rules. So, for example, you're not allowed to have the same colours touching, or flying Pokemon have got to be the right of other walking Pokemon. Can anybody tell me how many possible combinations there are of these 5 staff members? So we're looking at one combination. I can flip 2 around, I get another combination. Flip another 2 around, I get another combination. How many possible combinations do I have? Good, yeah, 5 times 4 times 3 times 2 times 1. 5 factorial, that exclamation mark we learned in school. It's got 120 possible combinations, some of which will satisfy the rules. Many won't, but only one will be the best one. Okay, let's make the problem a bit more complicated. So I've got 15 Pokemon. Can anybody tell me how many possible combinations there are? Don't say 15 factorial, that's cheating. How many possible combinations? Millions? Yeah, okay, so there's over 1 trillion possible combinations. To expect a human to solve this problem, we're wasting our time. In fact, one rule to take away with you today, anything more than 7, don't use a human for. Okay? Whether you're trying to figure out how to spend marketing money or allocate staff or route vehicles, anything more than 7, humans are useless. And actually, industry don't have problems of this size, they have problems of this size. So can anybody tell me how many possible, 500 Pokemon, can anybody tell me how many possible combinations there are? Guess? It's a big number. So it's a number that's over 1,000 digits. And just to put this number into context, this is how many atoms there are in the universe. Okay? And I would argue that you could probably solve problems up to about 7 if you're a smart human being. You could probably hire quite a smart computer scientist, graduate computer scientist, that can solve problems up to about 50 or 100. But if you want to solve problems like this at scale, you need a different set of skills I'm going to talk about in a second. But I want to just drum this problem home. Imagine I've got my ice cream van, and my ice cream van has got to deliver ice creams to these 24 points around London. And actually, humans are quite good at solving these spatial problems. So if we wanted to draw a path around these 24 points that saves us the most amount of petrol, maybe we'd start here and go here, and after a few minutes, we'd have quite a nice path around those 24 points. But how long will it take a computer to get the shortest path, the optimal solution? Seconds? Milliseconds? Okay, we played this game already. It's 20 billion years. So if you put 24 times 23 times 22 into your calculator, you get this number. And if you can have a computer that could look at 1 million routes a second, that could check 1 million routes a second, it would take longer than the age of the universe, 20 billion years, to go through every single possible one and say, this one that I looked at 20 billion years ago, this one's the shortest one. You should do that one. And if I had another point to the map, I've now got 25 times 20 billion years, 5,000 billion years. If I had another point to the map, it's 26 times 5,000 billion years. These are exponential problems. We hear the word exponential a lot when we're thinking about AI that can solve problems exponentially, but people fail to realize that we have thousands of these types of problems in industry that are exponentially difficult. And we have human beings solving them most of the time. So when Satalia thinks about building systems, we think about these 3 things. First of all, is the data available to help us find the insights using machine learning, using data science to find the insights that we need from the data. But ultimately, we want to make decisions. And decision-making is traditionally an optimization problem. And I would argue that organizations right now are going through their digital transformation. They're getting all of their data together. They're throwing lots and lots of machine learning experts at it, data scientists at it, to try and find patterns. But they're failing to realize you have to leverage that understanding to make good decisions. And I would argue that there are only about 3,000 really strong optimization experts around the globe. It used to be called operations research. It matured in academia about 20 years ago. Then everybody got excited about machine learning. But actually, there's about 3,000 people in the world that are really good at solving these problems at scale. And if you build a system that has these 3 things, that you give data to, you put it through a model, it makes a decision. Tomorrow, you give it the same data, it makes the same decision, same data, same decision. You have automation. But can anybody tell me what the definition of stupidity is? Okay, making the same mistake over again and expecting a different answer. I would argue that most systems in production are autonomous and are stupid. In fact, there are actually 2 definitions of AI. One I think is a popular one, but a little bit weaker than the second one. So the most popular definition of AI is getting computers to do things that humans can do. And the reason why this is popular is because humans are the most intelligent thing that we know in the universe. So when we start to get machines to do things that are traditionally only in the domain of human beings, like understand natural language and recognize objects and images, we then attribute that as being intelligence. When we start to get the machines to do things that are traditionally only in the domain of human beings, we call that AI. And the reason why I think that this is a bad definition is because benchmarking humans against machines is a silly thing. Because humans can find patterns up to about 4 dimensions. If I throw a ball at you in 5 dimensions, you're probably not going to be able to catch it. Machines can find patterns in hundreds of thousands of dimensions. If I asked you to solve problems beyond 7, you're going to really struggle. And computers can solve problems hundreds of thousands of different elements. So benchmarking humans against machines, I think, is a weak definition. The stronger definition of AI for me comes from the definition of intelligence. There's a very, very elegant definition of intelligence, which is goal-directed adaptive behavior. Goal-directed in the sense we're trying to achieve an objective. We have an objective or an optimization problem we're trying to achieve, whether it's to sell as many ice creams as possible or to allocate our staff as effectively as possible. You have to have a goal. Behavior is how quickly and frictionlessly can I move towards that goal, but the most important word in this definition for me is adaptive. If your system is not making a decision and then learning about whether that decision is good or bad and then changing its own internal model of the world, I would argue that it's not strong AI. And I've seen very, very, very few enterprise systems in production that are able to make a decision, learn about whether that decision is good or bad, and adapt its own internal model. That, for me, is the true paradigm of AI. Systems that are able to adapt in milliseconds as opposed to months or years. And with the project with PwC, we've solved this component. We've solved this. We can optimize staff at scale. And the next challenge is how do you then look at whether those staff have worked well together, whether they work well in teams, work well with clients, to then ultimately be able to optimize them better in the future. So ultimately we want to build adaptive systems, but building adaptive systems is extremely difficult. And I think I'm probably going to hand over now to...
All right. Thank you, Daniel.
That's all right.
Thank you. Daniel has talked about the enormity of the problems that are out there, and Charlotte and I are going to go into some depth about the enormity of the problem that we have solved, and the thing that we took from an idea through proof of concept, and I mean proof of concept, we didn't actually know whether we could do it, to pilot, to production in the UK, across our firm in 2 years and 2 months. And I think you'll agree with me when we're done that that was a terrific accomplishment, and that's why I'm so proud of the entire team, many of whom are here, both from PwC and Satalia, and will be available afterwards for the Q&A. So the problem that we solved is this one. So we solved the problem of scheduling over 4,000 people to over 8,500 projects, or as we call them, engagements, in the UK firm. And the good news about a constrained optimization problem is that when you solve it, when you get it optimized, not optimal, because you never get it perfect, you get to have more of all the things that you want and less of all of the things that you don't want. So what we wanted is we wanted to maximize demand fulfilled. We wanted, as far as possible, every single one of our projects to be fully staffed if possible. We wanted to distribute the workload evenly amongst our people to improve their quality of life and their opportunities. We wanted to minimize the travel time, which is also a quality of life issue. It's also an environmental issue. It reduces our carbon footprint, and it's just a cost. Unnecessary, necessary travel is great. We're all here. Unnecessary travel is just waste. And the fourth one is actually really interesting. So midway through, it wasn't one of the ones that we started out to solve. Midway through the project, someone had the bright idea of adding this one. And I'm sorry, I don't mean that sarcastically. It actually was a bright idea. And they said, look, there are gaps in the schedule. Susan is free half a day here. Fred is free for 2 days there. What if we could clump the free time? And this was one of the things that we added that was incredibly successful. We ended up with, Charlotte, was it 11? On average, 11 weeks of free time as single blocks of a week or more per person, which was fantastic. Now, it's a hard problem to solve, not only because of all the permutations and combinations you're talking about, but we also had a whole bunch of constraints. Now, those of you who are the optimization experts in the room will know that it's not really a clear binary thick line between whether something's an objective or a constraint. You can talk about some of them either way. I'm not talking about that. I'm talking about the way we understood the problem, not the way it was implemented, right? So what we did is we said we want to accomplish these 4 things, and at the same time, we have to deal with all of the constraints. We work in a number of regulated environments. We have to conform with a whole bunch of regulations and laws. We have a whole bunch of business rules that we've put into place to keep our quality where it needs to be, to treat our people well, et cetera. And there are some things that are just a bad idea, like putting me on an audit when I'm not an accountant. I mean, when I joined the firm, I was really worried about the numeracy test that I had to take. And my boss said, don't worry, don't let your team down, but don't worry, none of us have passed it. So we had, originally we thought there were 30 of these. Charlotte will tell you more about how it ballooned. So what we had to do with each one of them, each objective and each constraint, is we had to state them in English. And we first thought there were 30. When we got into it, we found that the English wasn't that clear. It wasn't rigorous enough to build something around. So the first part was simply getting the language really, really accurate. so that there were no contradictions and there were no gaps. Then for each one of the goals and objectives the same, and constraints, it had to be expressed mathematically, then it had to be expressed in code, and I'm going to click that so you can't take a picture because I don't think it's real anymore. It's an old version. But every one of them had to do that, and then of course all of those pieces of code had to work together. So we did that, and it worked. In fact, it's working right now. We've just completed another cycle, and is running as we speak. I was in the office one day, and someone came over and said, David, do you have a minute? I want to show you something. And they showed me this, and it was really clever, because we have lots of clever people, and they do all kinds of clever things. And they said, we've created a game. And the reason this is so clever is because it's really hard for us to understand the enormity of the problem. Daniel's thrown some numbers at you, I've thrown some numbers at you, but it's still really hard for us as people to understand how hard this problem is. So this looks like a really simple problem. You've got 4 people, you've got 1 week, you've got 3 locations. Okay? And what you need to do is you need to make sure that every shift is assigned, everyone gets a day off, and everyone is qualified. I looked at this and I said, great idea to create a game, great idea to help people understand what it is. It's too simple. And they said, try it. It took me 6 minutes. It's supposed to take 2. Right? I stared at the screen for 3 minutes trying to figure out what to do with it, because there are a bunch of things that make it non-optimal that I'm not going to go into today. But it was a massive learning experience for me to really understand how, your rule about 7. And most people, when they play us, it takes them 2.5 minutes. I've seen one person do it in 1 minute. The computer always does it in 1 second, and it always gets the best result. And so the reason I wanted to talk about this is partly because it's a really good anchor to all those really big numbers that, as Daniel said, we really don't understand. But also because this was a game that we first modeled in Excel. We then built it in Mini-Zinc, Charlotte keeps me honest, Mini-Zinc and Python, in about 2 weeks. So as much as there are a whole bunch of massive, big, complicated optimization problems that are out there that take the kind of effort we're talking about today, there are also a whole bunch of really little ones that probably don't take a lot of time, probably don't take a lot of effort, and are probably worthwhile doing. So to tell you how we got there, I'm going to turn over to Charlotte, someone who is one of the many people who did all the real work and all the hard work. Please welcome Charlotte Byrne.
Thank you, David. So to take a look at our journey to date, PwC and Satalia have been working together for over 2 years, and it's been a really exciting and transformative journey for us as a business. Our project has gone through 3 main areas, such as the proof of concept through to pilot, through to a full production rollout. However, over the 2 years, there's been a number of other stage gates and lessons learned for us, some of which I'll take you through today. So 2 years ago, when we decided to work with Satalia, we knew we wanted to do something around workforce optimization. What we weren't sure is what exactly we wanted to do. So we brought them in and we started collaborating and running some workshops in understanding the art of the possible with their technology, while also speaking to a number of different areas in our business and understanding their processes and pain points. From this, we established some selection criteria over the complexity of the technology, the impact we wanted to have, and how difficult of a challenge we were willing to take on. From this, we picked an area of the business that was most there in terms of operational and data readiness, but was also one of our most optimal areas of the business already, which set a real challenge for us in being able to increase efficiencies. But we thought if we're able to create efficiencies in this part of the business, we'll be able to create it across our whole network. Once we decided on the use case, we began carrying out research with 2 separate business units. In our organization, each business unit, while they collaborate, they work and operate somewhat independently and have their own kind of rules and procedures and ways of working. And what we were trying to do is build a single solution to solve this problem for multiple. So in doing this, we needed to drive change. Trying to drive change within areas of the business without having any benefits, research, or even knowing if it's going to really work at this point was a significant challenge. Going out of this research, we captured about 30 of those constraints David spoke about to bring into a proof of concept, where we accounted for the business rules, the operations, and organization processes. We applied weightings and prioritizations to each of these. For our proof of concept, we ran the schedules through our solution in parallel with the business as usual manual process so that we would have a benchmark to begin being able to measure the opportunity at hand. One of the key learnings from the proof of concept was the 30 rules that we had developed were effectively not enough. There was a number of nuances within the businesses that weren't clearly defined business rules or formal processes. They were just simple ways of working and behaviors that we hadn't accounted for. And once we accounted for these, refined the solution and added more rules, it took us from 30 to over 60 rules in our most latest release. During the pilot, when we were creating, after the proof of concept was successful, it gave faith in the product and that it was able to produce schedules that we were able to use within the business. It also gave us something to begin to measure what success looked like. We took this through to the pilot, where we removed the manual business process for 2 business units, which account for approximately 800 staff within our organization. We ran these schedules. We ran these schedules probably, I think, about 18 months ago. And from this, we took some key lessons. One was the data. We integrated into over 7 source systems and 100 data points. A number of these data points, our individuals within the organization were responsible for maintaining. And when people are responsible for their own data and what you're inputting, quite often you're working with incorrect or historical data. But once the business and people on the ground realized the impact that this was having on their day-to-day lives, where they were going to work, the teams and portfolios of work that they were getting, the quality of our data significantly increased overnight. So after a successful pilot to 2 business units and 800 people, we decided to challenge ourselves as a project team and go from 2 business units to 4, taking it from about 800 people to 1,500. And we started refining the rules, adding new parameters that we needed to in order for it to be acceptable by the business. And 4 months before go live, we had a very senior and ambitious member of our team say, "We've done it successfully for 2, I don't want 4, let's go for 13, taking it from 800 people to over 4,500 with 4 months notice and no move in the go live date. So this was a real challenge for us in scaling up what we had built, not just in terms of the business rules and parameters, but the infrastructure. We had built custom APIs to consume all of this data into the solution. When you're pulling data for 800 people, that's one thing, but when you're scaling it overnight to 4,500, the number of data points we were pulling from, this had a significant impact, and we had to refactor parts of the code and all of the APIs to ensure that we could consume it and how we needed. The challenge to roll out to 13 business units was set. We ended up rolling out to 11. And this was because we felt that there were 2 that simply weren't there as we got closer to go live in terms of data and or operational issues. Some might see this as a slight failing. However, I see this as a success for us as a project. We could have put those areas of the business live and through the tool, but taking that understanding of the impact of the technology and what it will do to your organization and being able to decide when it's not right was something that we're quite proud that we took that call to do it. And at the moment, back in the office, we're doing another annual planning process that's going live, hopefully by the time I get off stage, to another 10 of our business units within the organization. The future. So what are we planning to do moving forward in our collaboration with Satalia? At the moment, we're looking at how we can build a more dynamic, real-time solution that we can use on a daily basis to create updates to reflect the ever-changing dynamic organization that we have at PwC. What can optimization do for you? So what we've managed to solve over 2 years is an insanely large workforce optimization problem that has taken 2 years. As you've seen from the tool that David showed in the game, there's a number of much smaller problems in every organization, taking Daniel's rule of 7, that AI and optimization can be used to solve. So maybe for some of you here, it might be useful to take away and start where we did back 2 years ago in those workshops, and simply sitting down and analysing your business and how it operates and trying to identify any areas of challenge and having a think if AI or optimization could solve some of these problems for you. So that brings to an end our presentation for today, but we will be here on stage. I don't believe there's a talk after ours, so if anyone has any questions, feel free to come up to us. Thank you.
Quick one more.
Fantastic. So that was indeed the final presentation. What we're going to do is have a little meet the speaker session just at the front steps here. But just before we do that, what we're doing on all of the stages is just wrapping with some roundup messages for the whole of CogX. So if we can just pop those sort of 2-3 slides up, and I'll talk for maybe like a minute and a half, and then you can come and harangue these guys at the front. And Daniel can give you some more mental maths challenges. So it's been an extraordinary 3 days. We've had an extraordinary number of speakers. Thank you to these three for wrapping us up so well. A big part of the conversation here has been around how can we use technology to improve the world. And a focal point of that has been the 2030 vision around the Sustainable Development Goals. You'll have noticed the pins. The sharp-eyed of you will spot that I'm wearing a 17 Partnerships for the Goals t-shirts. So we're really excited to see where the conversation goes from here, and what we can all do to deploy these technologies at scale in the real world to make a difference on some of these pressing challenges. On a lighter note, we still have the ice cream van outside with an ice cream flavor for every one of the goals, if you want to sample those. To some extent, CogX, the festival, is a reflection of CognitionX, the knowledge platform that is obviously all part of the same family. And so what we hope that you've got out of these few days is an opportunity to make new connections, ask questions, hear interesting thoughts, and expand that sort of great knowledge network that we're all part of. The final thing after all of the talks is going to be a hackathon with that next generation, so talking about taking tech, putting it in the hands of people and doing great stuff. So if any of you are interested, at 2 p.m. in the research stage, which is just in the main area, there's going to be a Teens in AI hackathon, so go along and get hacking with the teens. But principally, I would love to say a huge thank you. It's an extraordinary amount of effort to get all of this working. It's actually, for me, it's the first time that I've been on the other side of the sort of Wizard of Oz screen. I'm normally the person who turns up half an hour before my talk, having just decided to shuffle all my slides around and kind of, no one can find me. Oh my God, the amount of work that goes on behind the scenes is unbelievable. So please do join me in thanking everyone who's made this possible. It's been a huge effort to do so.